Quadratic equation is one of the scoring topics of JEE syllabus. Every year there are one or two questions from this chapter. So what I am going to do in this one short video is, first I am going to tell you what are the changes in the JEE syllabus from 2023 to 2024. Then we'll systematically go into a mind map and see what exactly are the areas in this chapter and what is the scope of JEE Mains and Advanced. Next, in order to make your life super easy, I have divided this chapter into 12 problem types. I am going to systematically categorize all the problems that came into last 3 years and take all of those distinct problems with their theory and their technique to solve them in 12 problem types. So without any further delay, let us start with it. So if you look into the syllabus comparison of 2023 and 2024, virtually there is no change in the syllabus, but this syllabus do not paint the actual picture. Let us see what the actual JEE syllabus is. So if I talk about the actual syllabus of this chapter, this is the actual syllabus. So that means we start with solution of a quadratic equation. We discuss the relation between roots and coefficients. Then we move towards type of transformations, how to transform a given equation into a different equation with different kind of roots. How to apply Newton's theorem. Newton's theorem is a very important area for JEE Mains. Continuously year on year questions are asked on this. And students are completely unaware of what is Newton's theorem. Then we move towards the nature of roots, real roots, distinct roots, equal roots, imaginary roots. Then rational and integral roots. Then we move towards the idea of graph. So graph based problems are asked, problems based on range are asked, quadratic inequality based questions are asked. Then location of roots. So how it is located with respect to one constant, with respect to two constant, that is an important area. Then we take two quadratic equation and then we talk about how many common roots they are going to have. If I divide them, I get a rational polynomial and how to find the range of that rational polynomial. How to resolve a 2-degree quadratic equation in two variables, into two linear factors, and what is the condition for that. Then equations reducible to quadratic. So this is what actual JEE syllabus is, and let us start with discussion on problem type now. So the first kind of problem that you are going to encounter in the JEE paper is questions involving solving quadratic equation. Now what does this mean? You have three techniques to solve a quadratic equation. I can give you problems on each of these three ideas. So the first important idea is the quadratic formula. So what is a quadratic formula? Let us look into that. So a quadratic equation is defined as ax square plus bx plus c equal to 0. And there are two more conditions. First is a is not equal to 0 and a, b and c belongs to real number. These conditions are there. So the solution of this quadratic equation can be written as x is equal to minus b plus minus root of b square minus 4ac by 2a. Now this is what the answer is, or the roots of this equation are. Now here I am using the word roots and solutions interchangeably, but actually these are two different ideas. We are going to look into that when time comes. Another technique that you can use in order to solve this is splitting the middle term. And I think you have already learned the technique class 10th. So splitting middle term, I am not going to explain this technique because you already know it. The last idea, and that will be very important, would be creating perfect square. Again, we will be seeing how to create a perfect square using a question. So this last two technique will cover through questions, and the first one I have told you. Now let us see what question JEE asked in the exam. So if I look into this question of 2021, you can see they have given an infinite kind of a pattern that keeps on repeating. And if you look into the repetition, you will observe in this question that this part is getting repeated. So what we can do is, if I assume this to be equal to x, so what this becomes is 1 upon 5 plus 1 by x equal to x. And this is something very significant. If you know this logic or way of solving questions, then after this will become a quadratic equation. So if I solve this becomes x upon 5 plus 1 is equal to x. So if I take LCM, it becomes nothing but 20x plus 4 plus x is equal to 5x square plus x. So what I have done is I have taken LCM and multiplied on the right hand side. If I do this, what I get is 5x square minus 20x minus 4 is equal to 0. Now if I further solve it, what will I get? Using the quadratic formula, the answer will be 20 plus minus root of b square. That will be nothing but 20 into 20 minus 4. A is 5 and c is nothing but again minus 4. So this minus you should take care of because this can create a lot of problem. Divide by 2a, 2 into 5. So once I write this down, you can see that we have got the answer. But if I solve it further, I can cancel out a lot of things. Like I can take this 2 and I can cancel it out. So this will become 10. And inside this root, I will have to cancel 4. So this becomes 5. And again, if you simplify this, what you will see that what you're getting, the value of x is nothing but 10 plus minus root of, this will become nothing but 100. This will become plus, and what we have got is 20 by 5. And if I simplify, this is 10 plus minus root of 120 by 5. And if I simplify, what am I getting is nothing but 2 plus minus 2 by 5 root 30. If you look into here, we have got two signs here, plus and minus. Now, out of these two signs, this minus will never occur because the value of x is positive. If you observe this here, you will be able to neglect this negative sign and you will write the answer as 2 plus 2 by 5 root 30. And that is nothing but option A. So it is a very standard question. Multiple such questions has been asked in the exam. While making this video, I'm only taking distinct questions so that you are able to cover a lot of content in less amount of time. So if I look into this second problem type, what you will realize is, what are the important results that we have for this is, if I write ax square plus bx plus c equal to 0, the two roots for this would be nothing but alpha and beta. And if I consider these two roots, there are few results I can write. One is sum of roots, so alpha plus beta is equal to minus b by a. Then another root is if I take product of the roots, alpha into beta is equal to c by a. So these are two primary results that you need to know. Now there is one more result that if you know it is better, like the subtraction of the roots. So if I take this, it comes out to be nothing but root d by a. So how do we get this result? So alpha, if you write this as minus b plus root of b square minus 4ac by 2a, and beta if I write as minus b minus root of b square minus 4ac by 2a, and if I subtract them, what you will get from here is 2 root b square minus 4ac by 2a, or this can be written as nothing but root d by a. Okay, now see, I have introduced modulus here because we do not know whether alpha is more or beta is more. That is the reason I have introduced this modulus sign. If I look into this question that was asked on this idea, it talks about again 2 roots alpha and beta of this quadratic equation, and they're asking the value of this expression. So one thing that you should know about all such question is, we will never find the value of alpha beta, almost never. And most of the cases we will be solving this question by reducing the given question into a function of alpha plus beta and alpha beta, and then use our result of alpha plus beta and alpha beta. So if I find the value of alpha plus beta here, it is nothing but 64. And if I find the value of alpha beta here, it is nothing but 256. So we have got these two results from the question. Now let us reduce this question into alpha plus beta and alpha beta. So if I take LCM, what I am going to get is here is nothing but 3 by 8 plus 5 by 8. And again here we will get 3 by 8 plus 5 by 8. And the denominator after taking LCM, what you are getting is alpha beta raised to the power 5 by 8. If you simplify one more step, what you are getting is, in the numerator alpha plus beta, because 3 by 8 plus 5 by 8 will become 8 by 8, that is nothing but equal to 1. So this is what we are getting, and once I get this, I can put my values and get the answer. So if I put my values at 64 and 256 here, 5 by 8, I get my answer is nothing but 2. So it is quite a simple question, direct application of alpha plus beta and alpha beta. Now this 2020 question has two parts. In this first part, what they have given is the sum of the squares of the reciprocals. So if I write it, it is 1 by alpha square plus 1 by beta square. This is given as nothing but 15. This is my first part. And in the second part of the question, they are asking me the value of 6 alpha cube plus beta cube whole square. So our logic should be, in order to solve the second question, what you will require is the value of alpha plus beta and alpha beta. But if you closely look into the question, the value of alpha plus beta is nothing but minus lambda by 3. And the value of alpha beta that we know is equal to minus 1 by 3. So I know alpha beta, but I do not know alpha plus beta. For that I will require lambda. In order to find lambda, they have given us another condition. We can use this condition to get the value of lambda, and in the second part substitute value of lambda and get the answer. So now let us start from here. So if I take again my LCM, it becomes nothing but beta square plus alpha beta whole square is equal to 15. And now you can see the numerator, and these identities will be used time and time again. So if we have alpha square plus beta square, it can be written as alpha plus beta whole square minus 2 alpha beta, and this you have already done in class 10th and again then 11th. So if I do this, this is alpha plus beta whole square minus 2 alpha beta by alpha beta whole square is equal to 15. Let us put the value of alpha plus beta here. So if I put the value of alpha plus beta, it is nothing but minus lambda by 3 whole square. Minus 2 times minus 1 by 3, that is the value of alpha beta. And then if I divide it, it is nothing but minus 1 by 3 whole square is equal to 15. Now let us simplify and see what kind of value of lambda we are getting. If I simplify, it is lambda square by 9 plus 2 by 3 divided by 1 by 9 is equal to 15. And let us simplify a little bit more. So if I do that, it becomes lambda square plus 6 is equal to 15, or lambda square becomes equal to 9. That means the value of lambda can be plus minus 3. This is what we are getting. Now let us look into the question once more. Have they put some kind of condition for the value of lambda? No. You can see you can have two values of lambda, plus minus 3. Let us take the value of lambda is plus 3 first. Do the calculation and then ultimately take the value of minus 3 and then do the calculation. So you will have to make two different cases, solve for them, because sometimes your answer will match for one of the values and not for the other values. So it is a good idea to take both the cases. Let us check for the first case first. So what I can do is, in order to get this answer, I will have to first find the value of alpha cube plus beta cube. Now, in order to do this, we can again use our identity alpha plus beta into alpha square minus alpha beta plus beta square. Now, once you have done this, you can again realize you are getting alpha square plus beta square. So again, we can write that value as nothing but alpha plus beta whole square minus 3 alpha beta, because 1 alpha beta was already present. So if I put the value of alpha plus beta here, it was nothing but minus lambda by 3. So this will become minus 3 by 3. And this again becomes minus 3 by 3. And this is again 3 times minus 1 by 3. Now this is what we need to substitute. If I substitute, this becomes nothing but minus 1. This value becomes 1 plus 1. That is nothing but 2. So this whole value is becoming minus 2. So now the question is asking us the value of 6 times alpha cube plus beta cube whole square. So if I put the values, this becomes minus 2 whole square. So this becomes 6 into 4, that is nothing but 24. So we can see our option B comes out to be correct. Now in this next question, what they have given us is nothing but that the one root of this equation is cube of the other. So if I take one root as alpha, another becomes alpha cube. So the sum of the roots alpha plus alpha cube can now be written as minus k by 81. And the product of the roots, that is alpha into alpha cube, can be written as 256 by 81. Now from here, this can be written as alpha raised to the power 4. This can be written as 4 raised to the power 4 by 3 raised to the power 4. So you can see that alpha can have two values, plus minus 4 by 3. If I take this value and put it here, so what is going to happen? Let us put the positive value first. So this becomes 4 by 3 plus 4 by 3 whole cube is equal to minus k by 81. If you simplify this, the value of k comes out to be minus 300. So it is a very simple question. I could have also taken other value, but that option is not in the 4 options. So this is our answer. Now in this next question, what has been given to us is the value of p raised to the power 4 or q raised to the power 4. Now such 2-3 questions have been already there in JEE exams in the last 2-3 years. Let us see how to handle such questions. So what you need to do here is, you can see there are two parts of the question. First one talks about the value of p plus q. That is nothing but 3. So there is no problem with this part. The next part talks about p raised to the power 4 plus q raised to the power 4 is equal to 369. And the second part of the question talks about we have to find this value, and if I take LCM, it is p plus q by pq raised to the power minus 2. So minus 2 is fine, but what you will essentially need is the value of pq. So our target is p plus q, we already know. How can we use our basic quadratic logic to find the value of pq? So from here, we will find the value of pq, substitute and get the answer. That is how we are going to solve it. Now let us understand this. We have already done alpha square, beta square. That logic we can apply again. So if we have, this can be written as p square whole square plus q square whole square is equal to 369. So if I take this up, this is nothing but p square plus q square whole square minus 2 times p square q square. So if I write this, this is what you are going to get. Now still we do not know the value of p square q square. So we can find the value of p square plus q square separately by applying this formula of perfect square. You can see that this generating a plus b whole square formula is known as generating perfect square, and that is what I told you in the starting, that there are numerous questions based on this logic. So again, if I put this, the value of p plus q is given as 3, so this becomes nothing but 3 square minus 2pq. That is nothing but 9 minus 2pq. Now let us take this value and substitute above. If I do that, 9 minus 2pq whole square minus 2 times pq whole square will be equal to 369. Now you understand that pq is important, so let us assume pq to be t. So this is nothing but 9 minus 2t whole square minus 2t square is equal to 369. This is now much more simpler to solve. If I open it up, it is 4t square plus 81 minus 2 into 9 into t minus 2t square is equal to 369. Now if I take this one and this one, this becomes nothing but 2t square. If I simplify this part, it is nothing 4 into 9, 36. And then what we have got is nothing but this 81 and minus 369 equal to 0. T square minus 36t minus 288 equal to 0. I can divide by 2, and if I do so, what I get is t square minus 18t minus 144 equal to 0. So this is the quadratic that we are getting. What we need to find is the value of t. For that, we can apply the quadratic formula now. So 18 plus minus root of b square. So b square would be nothing but 18 square minus 4a and c. So this will become this one and divide by 2a. So we can divide by 2. So if I divide by 2, I can take this 2 inside. So this will become 9. And this will, you will see I will do it often. This will become 9 square. Why we are doing this? Because see, this will make our calculation simpler. So if I do this, this is 9 plus 144. 9 square plus 144. And that could be further simplified. Let me write it here. The value of t comes out to be 9 plus minus root of 81 plus 144. Now what is 81 plus 144? So if I add it down, it becomes nothing but 144 plus 81. This becomes 5. And this if I add becomes 2 and 1. 225. So what you can see here is what we are getting inside this root is 225. And if I write this up, this is 9 plus minus root of 225. That is nothing but 15 square. So this is nothing but 9 plus minus 15. So we are getting two values of t. The first value is nothing but if I take plus sign. So if I take plus sign, what I get is nothing but 24. And if I take minus sign, it will get subtracted and what we'll get is minus 6. Now let us check the value of the expression for both of these values. So now here, p plus q we already know is t. Here now there are two values possible. If I put 24 here, one value, and another when we put minus 6 here, another value. So corresponding to this first value, we can see this will become 8. Our answer comes out to be 8 square, that is nothing but 64. And corresponding to this next value, the value comes out to be nothing but 2 square, that is nothing but 4. So we are getting two values, 64 and 4. So now the question that is in front of us, which of this is the correct answer? Is 64 the right answer or the 4 right answer? So for that, there is an additional layer in the question. So if you look into this question, there is one innocent looking condition given. P and Q are two real numbers. So this condition is very important because this is going to decide the fate of this question. So in the third part, if I take P plus Q is equal to 3 and PQ is equal to 64, let us see what will be the value of P and Q then. So if I substitute here, this becomes nothing but P plus 1 by, now this it can be written as 64 by P is equal to 3. And if I simplify this, this becomes P square plus 64 is equal to 3P. So P square minus 3P plus 64 will be equal to 0. And you can see that the D for this or discriminant comes out to be smaller than 0. So the roots are not real. So this answer that we got earlier, 64, cannot be accepted because for this P and Q will not be real. Wherein if you do the same thing for the other answer, that is nothing but 4, you will get the right answer. Both P and Q will be real. Now we can see that again the same concept of alpha raised to the power 4, beta raised to the power 4 has been asked in this question. So what we are going to do the same thing. Again we can write this as alpha square plus beta square whole square minus 2 alpha square beta square. This is the same thing we did in the last part. And again this can be in turn written as, so alpha square plus beta square can be in turn written as alpha plus beta whole square minus 2 alpha beta. So we are applying the same concept twice, and now we can see that at least 3-4 times JEE has asked this idea. So this problem solving concept is very important. Alpha plus beta value if I put from here, it is nothing but minus of 60 raised to the power 1 by 4 whole square. And now this another 2 alpha beta can be written as A. So if I simplify this, what I am getting is nothing but 60 raised to the power 1 by 2 minus 2A. And this is what is the value of alpha square plus beta square. Let us substitute it here. And if I substitute, this is my first part of the question. If I substitute here, it is 60 root of 60 minus 2A whole square minus 2 alpha square plus beta square. So alpha beta we can see again will be equal to A square, will be equal to minus 30. Again, if I simplify from here, this comes out to be 60 plus 4A square minus 4 root 60A minus 2A square is equal to minus 30. So again, if I simplify, this becomes 2A square minus 4 root 60A, and we will have 90 is equal to 0. So you can see that again similar kind of conditions like in the same last question we are getting. And if I keep simplifying it, this is what I get. Now let us understand what they're saying is product of all possible values of A. That is what they're asking us. So they are not asking us basically find the value of A. The second value, what they're asking is if this is a quadratic equation. So now we have got a quadratic equation that looks like this. So take a moment, pause things up and think what they're asking. So what they're asking is, if you have this quadratic equation, there are going to be two values of A1 and A2. So they want the product of the roots. The product of the roots can be directly written as 45. So you are directly getting your answer after second step. So it is even simpler than the question that was asked earlier. Again, similar type of question can be done without sweating it out. So now this question, we have got the value of alpha plus beta as nothing but 3 by 7. And alpha into beta is equal to minus 2 by 7. And what we want is the value of this expression. Let us convert it into a function of alpha plus beta and alpha beta. For that, let us take LCM. So alpha into 1 minus beta square plus beta into 1 minus alpha square divided by 1 minus alpha square into 1 minus beta square will come. And if we simplify, it is alpha minus alpha beta square plus beta minus alpha square beta divided by 1 minus alpha square minus beta square plus alpha square beta square. Now if I convert this into a function, if I take alpha and beta, it becomes alpha plus beta. And again, if I take alpha beta common from the next two terms, it becomes alpha plus beta. And again, this bottom part can be written as nothing but alpha plus beta whole square plus 2 alpha beta plus alpha beta whole square. So you can see that everything now is in terms of alpha plus beta and alpha beta. We can substitute the values in the second part and get to the answer. So in the second part, just substitute the values. So alpha plus beta is nothing but 3 by 7 minus 2 by 7 into 3 by 7 divided by 1 minus 3 by 7 whole square plus 2 times, and then alpha plus sign is there here, and then what we have is again a 3 by 7 whole square. Simplify this, and once you simplify, your answer comes out to be 27 by 16. If I look into this next question that was asked in 2022, it looks like a question which has multiple parts. Like they are talking about this quadratic equation first that has roots alpha and beta. Then they are talking about the roots of another equation that are again given as 1 by alpha square plus 1 by beta square plus 1. From this equation, it seems like we have to find the value of A and B and then put it here to get to the answer. But if I observe something very carefully, this approach will get very simplified. So instead of doing this, if I observe this, that what we have to find is not A and B, but the value of A plus B. And the life becomes very easy, because if I want to write the value of A from this equation, it is nothing but can be expressed in terms of sum of the roots. So the sum of roots is nothing but 1 by alpha square plus 1 and then 1 by beta square plus 1. So if I do this, I can find the value of minus A. And then again, if I multiply them, I will be able to find the value of that is nothing but product of roots, that in this case is nothing but B by, that is nothing but B by 1. And once I've done this, what I get, if I find the value of A plus B, this question will become very short. So let us do that. So if I simplify this, this comes out to be 1 plus alpha square by alpha square plus 1 plus beta square by beta square is equal to minus a. So the value of minus a comes out to be beta square plus alpha square beta square plus alpha square beta square by alpha square beta square. So if you simplify this, the value of a comes out to be minus of alpha square minus of beta square and minus of 2 times alpha square beta square by alpha square beta square. Now similarly, if I find the value of b, it is much simpler than this, and if I do that, the value of b comes out to be nothing but 1 plus alpha square into 1 plus beta square in the numerator by alpha square beta square, and your denominator is already matched, and numerator also, if I simplify, it is 1 plus alpha square plus beta square plus alpha square beta square divide by alpha square beta square. So if I do this much, what I can say is I have got the value of a and b. Using this, now our target is to find the value of a plus b, and if I do a plus b, it is very simple because a lot of things are getting cancelled out. So if I write it down, what ultimately would be remaining is 1 and 1 alpha square beta square divided by alpha square beta square. See, now it is easy to find because we know the value of alpha beta from first equation. So if I look into my first equation, the value of alpha beta from here is nothing but root 6. So let us take this value and substitute it here. And if I do so, I get the value of a plus b. That is nothing but 1 minus 6 by 6. And that is nothing but minus 5 by 6. The first part of the question is done. Now let us move towards the next equation that is given to us. So if you look into the next equation, it is x square minus a plus b minus 2 into x. And then a plus b plus 2 equal to 0. So this is the next equation that is given to me. If I solve this next equation, what I am observing is the value of a plus b will come out to be minus 5 by 6 minus 2 into x and minus 5 by 6 plus 2, 5 by 6 plus 2 equal to 0. So if I simplify, this becomes x square minus 17 plus 17 by 6 plus 7 by 6 equal to 0, or 6x square plus 17x plus 7 equal to 0. Now this is not the question. What they're asking is what is the nature of roots of this equation. That is what the actual question is. So in the third part now, what I can do is I can find the roots of this equation. If I find the roots, it is minus 17 plus minus root of b square. That is nothing again 17 square minus 4 a and then c by 2a. So if you look into this part, now two things you should observe. This thing that is written inside the root, that is nothing but our d, is greater than or equal to 0. This is greater than 0. That would mean it will have real roots. That is one. And the second thing that you will observe is this value of d that we are getting inside this root. Now this is going to be smaller than 17 because 17 is square minus something. So obviously it is smaller than 17. So what we can observe is, since this value here that we have writing, that is root d, this value is smaller than 17. So when we add and subtract, ultimately we are going to get negative answers. So once you observe these two figure things very clearly, now let us go to the options. So you can see that real is given in 3 options, but negative is only given in 1 option. So your option B becomes the correct answer. Now if I look into this 2019 question, it is again a very simple question. What they have given is the value of lambda is nothing but the ratio of the roots. So if I take this value of lambda and put it here in this equation, lambda plus 1 by lambda, it is alpha by beta plus beta by alpha is equal to 1. And if I simplify this, what am I getting is nothing but alpha square plus beta square is equal to alpha beta. And if I further simplify, it is not something very difficult. We can find the value of alpha plus beta whole square minus 2 alpha beta is equal to alpha beta. And now alpha plus beta whole square will be equal to nothing but 3 alpha beta. Now let us substitute the value. So the value of alpha beta from the above equation is minus m into m minus 4 by 3m square whole square. And this value, if I put it here, it is nothing but 2 by 3m square. So if I simplify this, what am I getting? You can see this m will get cancelled out, and what I am getting is m minus 4 whole square by 9m square will be equal to 6 by 3m square. And again this 3 I can cancel out, m square will also get cancelled out. So ultimately from here the value of m minus 4 whole square, and this is nothing but the second part. What we are getting is nothing but 18. And from here, if I try and figure out the value of m comes out to be 4 plus minus root 18. Now, since I want the least value, the question clearly talks about the least value of m. So it is going to be 4 minus root 18, and that is nothing but our option C. Quite a simple question, simple calculations you can do. Now in this 2020 question, obviously you know the long cut of solving this question. Find the value of alpha plus beta, and from there you can proceed. But I am giving you a even more shortcut for solving such kind of question. So what is that shortcut? See, whenever such kind of questions are given, you can assume some values. Like here, if you see, the value of product of the roots is given as 2. And the sum of the roots, if I write it, is given as minus p. So if I take the value of alpha as 1 and the value of beta is 2, you can see the value of p I can find from here would be equal to minus 3. And if I've got this information from first equation, from second equation, the value of 1 by alpha plus 1 by beta will be equal to nothing but minus 2q by 2. So from here, if I simplify it, is 1 plus 1 by 2 will be equal to minus q, or q comes out to be minus 3 by 2. Now in the third part, let us check what they're asking. So if I look into what they're asking, and if I put the value of alpha and beta here, the first term will become 1 minus 1, rest I can write. And since 1 minus 1 is 0, the value of this expression becomes 0. So I want one of the options from A, B, C, D, which is actually, if I put the value of P and Q, will become 0. So if you look into this option D, specifically in this option D, if I put the value of P as minus 3, you can see that this option becomes 0. So directly you can take this option and move forward. What I've done is, I have assumed the value of alpha and beta. From there I got the value of P and Q. That value I've satisfied in other parts of the question also, and options also, and verified which option will match. Now this approach will work in lot of questions which talks in terms of constants A, B, C, D, P, Q, R, S, and it is a very neat trick to solve all such questions. Now this is based on another property that is there between the roots and the equation. So now if I can write my general quadratic polynomial, fx is nothing but a into x minus alpha into x minus beta. This I can write using factor theorem, because alpha and beta are the factors. X minus alpha, x minus beta are the factors. So now what they have given is, they have given the value of beta here. They have given the value of beta as minus 1. If I want to write this polynomial, and this is the first part of the question, can be written as a into x minus alpha into x plus 1. So once you have written this value, now let us look into what is the condition that is given to us. So a condition that is given is f of minus 2. So if I put minus 2 here, it becomes a into minus 2 minus alpha. This becomes minus 1. So it is nothing but a into 2 plus alpha. And if I figure out the value of 3, it is nothing but a into 3 minus alpha and 3 plus 1. So it is nothing but 4a into 3 minus alpha. Now let us add this down, and what they're saying is, if I add them, it comes out to be 0. So a into 2 plus alpha plus 4a into 3 minus alpha will be equal to 0. A we can cancel out. What we have got is a condition between alpha. So this is 12 minus 4 alpha is equal to 0. So this becomes 14 minus 3 alpha is equal to 0. So from here, if I figure out, the value of alpha is actually coming out to be 14 by 3. See, now the second part of the next part of the question says, find the sum of the roots. So sum of the roots is going to be alpha plus beta. If I find the value of alpha plus beta, I will get my answer. So if I put this value, it is nothing but 14 by 3 plus minus 1. And now if you simplify this is going to be 11 by 3. And 11 by 3 is nothing but option A. Now this question is nothing but a combo of two different ideas. One is the idea of centroid that we learn in straight lines, and the second one is nothing but the relation between the roots and the coefficients. So there are two parts. So let us consider both of those parts separately, then try and connect them. So the first is, they are talking about centroid of a triangle whose vertices are given to us as a comma c, then 2 comma b, and then nothing but a comma b. So if I actually write the centroid of this triangle, this would be a plus 2 plus a by 3. And the value of x coordinate is also given as 10 by 3. So let us substitute this value. So what we have got is 2a plus 2 is equal to 10. Or 2a will be equal to 8, and the value of a comes out to be 4. So this is the first part. Now, if I do the similar kind of activity for the another coordinate, what we will get is C plus B by 3, and this is also given as 7 by 3. If I write the relation, 2B plus C would be equal to 7. So this is what we are getting after solving this equation. This is the another part. Now what we can understand is there is one more thing given in the question, that is the relation of arithmetic progression. So what they are saying is ABC and arithmetic progression. So from here the question transitions into a question of AP. So here what we understand is 2B will be equal to A plus C, and 2B and A here we can put as 4 plus C. And now we know from here there is a relation between 2B and C. From here let us put the value of 2B. It comes out to be 7 minus C is equal to 4 plus C. And if I simplify this, what am I getting is nothing but 3 will be equal to 2C, or C will be equal to 3 by 2. Now once we have got the value of C, from here we can also get the value of 2B. So 2B is nothing but 7 minus C. So 7 minus 3 by 2 if I put, it would be nothing but 14 minus 3 by 2, 11 by 2. So your B comes out to be 11 by 4. So now we have got the value of ABC all. So after this question transitions into a question of quadratic. So in the third part, what they are saying is, if I move towards the third part of this equation, they are talking about a quadratic equation ax square plus bx plus c. So if I write ax square, it is 4x square. B is nothing but 11 by 4. X plus 1 equal to 0. And they are saying that this equation has two roots, alpha and beta. So if I write product of roots, it is going to be minus 11 by 4 by 4. So it is nothing but my 11 by 16. And if I find the value of alpha into beta, it is nothing but 1 by 4. So we have got both these values. Now in the next part, what they want us to find is the value of alpha square plus beta square minus alpha beta, and this we have done multiple times. So if I just take alpha plus beta whole square minus 3 alpha beta, I will get my answer. So if I put the values here, it is 11 by 16 minus 11 by 16 whole square minus 3 times 1 by 4. And if I simplify this, I get nothing but minus 71 by 256, and that is nothing but option 4. So you can see there are three parts of the question. The first part is coming from coordinate geometry. The second part is coming from AP. And then there is a third part that is of quadratic. Most of the times you will find such kind of questions in JEE Mains. Now this next question is nothing but a combination of trigonometry and quadratic. So what they are asking is, they are asking the value of this term. Now we know that all such questions will involve the use of sum of roots, that in this case will become minus sine theta, and the product of roots, that in this case becomes nothing but 2 sine theta, minus 2 sine theta. And we also know difference of the roots that we have done earlier. It was nothing but root of d by a, if you remember that. So that also becomes b square, that will be nothing but sine square theta plus 8 sine theta. So these are the information that are available to us. Now let us try and simplify this expression that is given to us. So this is the information. Now simplification, if I do, this is alpha raised to the power 12 plus beta raised to the power 12. If I again write, this is 1 by alpha raised to the power 12, 1 by beta raised to the power 12 into alpha minus beta raised to the power 24. This can also be simplified and written as alpha raised to the power 12 plus beta raised to the power 12 by alpha raised to the power 12 beta raised to the power 12 by alpha beta raised to the power 12. And this is alpha minus beta raised to the power 24. You can see that this term is getting cancelled out. And if I cancel out this term, something very beautiful happens. That is, now we are getting the value of this expression in terms of two quantities that we already know. Alpha plus beta raised to the power 12 by alpha minus beta raised to the power 24. If you substitute the values, let us see what we get. So alpha into beta can be put as nothing but minus 2 sine theta raised to the power 12, and alpha minus beta can be put as nothing but sine square theta plus 8 sine theta, 8 sine theta raised to the power 24 divided by 2. So if I simplify this, what am I getting is, it is 2 raised to the power 12 into sine raised to the power 12 theta. From denominator also I can take 1 sine theta out. It is sine raised to the power 12 theta. And what is left is sine theta plus 8 raised to the power 12. So again you can see that your A option matches, and that is our answer. So you are looking little bit of trigonometry and a lot of quadratic to solve this question. Now, if I look into this next question, it is a very interesting question that was asked in JEE 2022 based on ABC property of log. Now, let us look into first what is the ABC property and how it is getting applied in this question. So you have two important properties of log. The first one I call is ABC property. If you have log of a raised to the power log of c to the base b, you can write this as c log of c raised to the power log of a to the base b. You can see that a and c are getting interchanged. And another important property is base change formula. So if you have log of a to the base b, I can write this as 1 of log of b to the base a. So this is based on these two very important properties. Now, if you look into these two parts in this question that they are talking about, we can simplify this. And the simplification would be same for this two part. So I'm only going to show you one, not the both. So if you have 3 raised to the power root of log of 5 to the base 3, this 3 that we have, we can write this 3 as nothing but 3 raised to the power log of 5 to the base 5 to the power root of log of 5 to the base 3. And if I solve this further, what I can do is I can write this as 5 log of 3 to the base 5 raised to the power root of, now this root also, here I can apply base change formula, and this power can be written as 1 by root of log of 3 to the base 5. You can see that now this quantity and this quantity we can simplify again and becomes root of log of 3 to the base 5. So if you closely observe now, this quantity that we have written here have come out to be equal to this quantity. So if I simplify, both of these quantities should ideally get cancelled. So the equation after simplification will look something like this. So this 5 would be there, but this also becomes 5 raised to the power root of log of 3 to the base 5. And this also becomes the next part. You can see that both of them are getting cancelled out. The similar phenomena also happens with the remaining part of the question. So if I write these two quantities, this will also follow the same kind of relationship. So this can also be written as 5 raised to the power log 3 to the base 5 raised to the power 2 by 3 minus 5 log of 3 to the base 5 raised to the power 2 by 3 minus 1 equal to 0. So once you write this down, what we will see is these two very important quantities, they were generating a lot of trouble for us, are getting cancelled out now. And what we can get is a very simple equation, x square minus 5x minus 3 equal to 0. Now the first part of question says that this is the first part of question. The second part of question, what is given to us is we want to find an equation whose roots are alpha plus 1 by beta and beta plus 1 by alpha. Now the roots of these two equations are alpha beta of the first equation. So now see, if you look into the 4 options, I do not actually need to find that equation. I just need to find the product of roots, because in all the 4 scenarios, the product of roots is different. If I just find the product of the roots, I should get the answer. So what I ideally need to do is, instead of finding the equation, I can multiply this and find the product itself. So if I multiply them, what will happen is it will become alpha beta plus 1 plus 1 plus 1 by alpha beta. So what you're ideally getting from here is nothing but alpha beta. If I substitute from this equation, it becomes minus 3 plus 1 plus 1 plus 1 by minus 3. And what we are actually getting from here is nothing but minus 1 minus 1 by 3. So what I am ultimately getting is minus 4 by 3. Now let us check the options, and you can see that only option B satisfies this condition for product of roots. So product of roots for this B option is nothing but minus B by A, C by A. It is minus 4 by 3. So our B option becomes the correct answer. You can see I have used a lot of shortcuts in this question. The first is this ABC formula, then the base change formula. Ultimately simplifying this equation and just not writing the equation, just the product of the roots and comparing the options.
Now in this 2024 question says that there are 2 roots of the equation already given to us. So the first root that is given to us is nothing but 2, another one is given as 6. So now if I find the sum of the roots, it is going to be 2 plus 6, and this will be equal to minus b by a. Wherein if I find the product of the roots, it is going to be 2 into 6, that is going to be nothing but 12, and this is equal to c by a, c is nothing but 1. So from the second condition, directly we get the value of a is nothing but 1 by 12. Similarly, from the first condition, if I substitute this value, 8 minus 8 comes to b equal to b by a. So b comes out to be minus 2 by 3 if we put a is equal to 1 by 12. Once we have done that, the next part of the question, it says that the new roots of a new quadratic equation are twice of a plus b. Now if I write twice of a plus b, the first thing that you are going to notice is the value of 2a here is going to become 1 by 6, b is still minus 2 by 3. If I take LCM, this becomes 6 by 1 minus 4, answer comes out to be minus 2. Similarly, if I want to find the value of beta or the another root, it will become 1 upon 6a plus b. If I substitute the value, 6a will become 1 by 2, b will become minus 2 by 3, and if I simplify, this becomes 6 divided by 3 minus 4, answer comes out to be minus 6. Now by doing this, we have figured out both the roots of the equation. Now in the third step, if I want to find the new equation, it is x square minus sum of roots into x plus product is equal to 0. If you find the sum of the roots, it is going to be minus of minus 8x and product is going to become 12. Once we have done that, the answer comes out to be quite simple. It is x square plus 8x plus 12 equal to 0. And if I check my option, you can see that my A option matches. Now in this next equation, we have been given an equation x square plus 2 root 2x minus 1 is equal to 0. And we have been asked an equation whose roots are alpha raised to the power 4 plus beta raised to the power 4. And 1 by 10 times alpha raised to the power 6 plus beta raised to the power 6. So what we are going to do is, first we are going to find the value of alpha raised to the power 4 plus beta raised to the power 4. Now if you want to find alpha raised to the power 4, beta raised to the power 4, this can be written as alpha plus alpha square beta square whole square minus 2 alpha square beta square. And now we know that the equation that is given to us also provides us the value of alpha plus beta, that is minus root 2, and then alpha beta, that is equal to minus 1. So from here I can get the value of alpha square plus beta square by squaring it. So if I square it, this is what we get, and this becomes nothing but 8. Now alpha beta is minus 1. So you can see that alpha square plus beta square, if I try and figure out, will become equal to 10. Now let us substitute the value. So this is nothing but 10 square minus 2 times minus 1 whole square. So what we are getting is 100 minus 2, that comes out to be 98. This is the first part, first root we have figured out. Now for finding the second one, we will have to find the value of alpha raised to the power 6 plus beta raised to the power 6. So we can write this as nothing but alpha square whole cube plus beta square whole cube, and that can be in turn written as alpha square plus beta square alpha raised to the power 4 plus beta raised to the power 4 minus alpha square beta square. Now we know the value of alpha square plus beta square, this is nothing but 10. Alpha square plus beta square we have figured out, this is nothing but 98. And alpha beta we know is nothing but minus 1. If I do this calculation, it is 10, 98 minus 1. So this is 970. Now they have also given 1 by 10. So if I want to write another root, it is 1 by 10 alpha raised to the power 6 beta raised to the power 6. So if I divide by 10, this comes out to be 97. So now we have got both the roots. After this, if I want to write the equation, then this equation can be written as nothing but, in the next part, third part, is nothing but x square minus sum of roots. So 97 plus 98 will come, and in the product 97 into 98 will come equal to 0. So this is the final answer. Now let us check the options. So if I check the options, 97 plus 98 would be nothing but 200 minus 5. 200 minus 5 will be 195. So either B or D option can be correct. We will also have to figure out the multiplication of 97 to 98. That you can do, and ultimately option B will match. Now this 2024 question talks about a equation px square plus qx minus r equal to 0. In this equation, if you see, they have given two roots alpha and beta in such a manner that p, q, r are in nothing but consecutive terms of a non-constant gp. That would mean if I consider the first term as nothing but a, then the second will become a capital R, and the third will become a capital R whole square. So this is nothing but p, this is nothing but q, this is nothing but r. So if I substitute all of these values in the equation that is given to me, it becomes ax square plus ar x, and then you have a minus sign, so minus AR square equal to 0. If I simplify it, is x square plus Rx minus R square is equal to 0. So this is what is given to us. Now once you look into this equation, another thing that they are talking about is nothing but if alpha and beta are the roots of the equation. So we know that the value of alpha plus beta from here would be nothing but minus R. The value of alpha into beta from here would be nothing but minus R square. So what they have given us is nothing but value of 1 by alpha plus 1 by beta, and this is equal to 3 by 4. If I simplify this, it becomes alpha plus beta by alpha beta is equal to 3 by 4. And if I substitute the value here, let us see what do we get. So what we get is nothing but minus R divided by minus R square, this is equal to 3 by 4. So the value of R from here comes out to be minus 4 by 3. Now we have got the value of R. What they are asking is alpha minus beta whole square. So alpha minus beta whole square can be in turn written as alpha plus beta whole square minus 4 alpha beta. And if I substitute the value, this will be minus R whole square. And this will be plus 4 R square, because alpha beta is minus R square. Let us substitute the value. This is 4 by 3 whole square with a minus sign. It will become plus. And then this will become 4 times 4 by 3 whole square. So if I simplify this, this comes out to be 80 by 9. That matches option D.
Now let us look into this next problem type, that is known as Newton's formula or Newton's theorem. This Newton's theorem has been very important if you look into JEE questions. A lot of questions based on this idea have been asked. Now first let us understand what is Newton's theorem. So we'll take an example to show it because it is easier that way. So if we have x square minus 3x plus 2 equal to 0. And let us say that this equation has two roots alpha and beta. So what Newton's theorem says is, if I put alpha here, it becomes alpha square minus 3 alpha plus 2 equal to 0. And if I put beta here, it becomes beta square minus 3 beta plus 2 equal to 0. Now if I multiply the first equation by alpha raised to the power n minus 1. So this becomes alpha square minus 3 alpha plus 2 equal to 0. And the similar thing if I do with the second one, I multiply by beta raised to the power n minus 2. Yes. So what I get is nothing but a very beautiful result. So one more step, and if I simplify the first one, it becomes alpha raised to the power n minus 3 raised to the power alpha raised to the power n minus 1 plus 2 raised to the power alpha raised to the power n minus 2 equal to 0. And if I write the second one, it is beta raised to the power n minus 3 raised to the power beta raised to the power n minus 1 plus root 2 raised to the power beta raised to the power n minus 2 equal to 0. And now I can do two different things. First, I can add both of them. So if I add both the results, what I get is alpha raised to the power n plus beta raised to the power n minus 3 times alpha raised to the power n minus 1 plus beta raised to the power n minus 1 plus 2 times alpha raised to the power n minus 2 plus beta raised to the power n minus 2 equal to 0. This quantity, we can give it multiple names. I am calling it Sn. This becomes Sn minus 1, and the second one also becomes Sn minus 2. And this is a very important result, will be used in multiple ways. So what Newton says is, if you have got this first result, from here itself you can write the Newton's formula or idea. So instead of x square you can write Sn. Instead of x we can write Sn minus 1, and instead of this constant 2 into 1 we can write Sn minus 2. So if I do this, this is known as Newton's theorem. It is as simple as that. Now whatever I have done for addition can also be done for subtraction. So had I taken this 1 and subtracted 2 from it, this relation would have been alpha raised to the power n minus beta raised to the power n. 3 times alpha raised to the power n minus 1 minus beta raised to the power n minus 1 plus 2 raised to the power alpha raised to the power n minus 2 minus beta raised to the power n minus 2 equal to 0. And you can see that if I call this quantity as Rn, so this is Rn minus 3 times Rn minus 1 plus 2 raised to the power Rn minus 2 equal to 0. So again, either you add or subtract, the result does not changes, and this is known as Newton's theorem. So you do not need to do this much. All you need to do is when you look into the equation, you can directly write this result and you can solve questions thereafter. Now let us see what kind of question JEE has asked on it. The first kind of question that will appear in the paper is directly Newton formula based question or Newton theorem based question. So what you can do is in this part, you can see that the Sn is also given to us. If I just directly write it down, I will get my answer. So 5 Sn plus 6 Sn minus 1 minus 2 Sn minus 2 is equal to 0. You can see that this is a question. All they have done is they have put the value of n in the Newton's formula or the Newton's theorem. So if I want to verify the results, it is not very difficult. All you need to do is in place of n just put 6 and you have got your answer. So it is like a 30-second question that you can do really fast. So this becomes 5 times S6 plus 6 times S5 minus 2 times S4 is equal to 0, and you can see only one option, that is option A, is satisfying it. Now if I look into this next question that was asked in 2013, then 2015 and 2022 multiple times. This is a same Newton's formula. In place of, you can see Sn, they have written Rn. In this case they are referring that to as An. Does not matter, we can again apply the same thing. Replace a square by An, x square by An, x by An minus 1, and the constant part with An minus 2 is equal to 0. Now we can see that here instead of n they have put the value as 10. If I put 10 here, it is a10 minus 6a9 minus 2a8 will be equal to 0. So if I keep this 10 and 8 part on the same side and take the 6a and 9 on the other side, I can divide this part and I can get the expression that is given to the question as 2 into a9 in the denominator, and you can see the answer comes out to be 3. So again, a very single liner type of question is given to us. This is nothing, again option C. Now in this next question, what we need to do is again apply the Newton's theorem. So I can write it as pk minus p k minus 1 minus pk minus 2 is equal to 0. So what you can do is, in order to find the value of, now you can see it is playing with p5, p4, p3, p2, p1. So let us start with p5. So if I find p5, it is p4 minus p3 equal to 0. Now we can see that none of these values we know. So let us start with again 4. So p4 minus p3 minus p2 equal to 0. So here we have put k is equal to 5. Here what we are doing is we are putting k is equal to 4. The next part, what I can do is I can put k is equal to 3. So this is what we are getting. 3. So now once you have done that, what you can do next is put the value of k as nothing but 2. So p2 minus p1 minus p0 will also be equal to 0. Here k is equal to 2. Now see, we can have this, we have a recursive relation kind of a situation. P0 if you want to find, it is very easy to find. It is alpha raised to the power 0 plus beta raised to the power 0. It will come out to be 2. P1 if I want to find, it is alpha plus beta. And from this equation, if I want to find the value of alpha plus beta, it is equal to 1. So once you have this, from this first equation that we have here, we can find the value of P2. So P2 if I find, it is nothing but P1 plus P0. P1 plus P0 comes out to be 3. And once we have figured out this value, now we can put P2. So P3 can be written as nothing but P2 plus P1. P2 is 3, P1 is 1, so it becomes 4. And now P4 if I want to write, again I do the same thing, P3 and P2 I can add. So P2 was nothing but 2, P3 is nothing but 4. If I add them, what I get is 7. And P5 again if I want, it is nothing but P4 plus P3. That comes out to be 11. Now let us check the options that are in front of us. We have been given 4 options. So the question categorically says that which of the options are not correct. If I check, P5 is not equal to P2 into P3. So this option is not correct, hence the correct answer. You can check other options also and see whether they are true or not. In this next question, we need to manipulate the Newton's theorem and come up with this encircled result. So if you look into the question, Newton's theorem, we have Sn minus 7 times Sn minus 1 minus Sn minus 2 is equal to 0. If I rewrite the question, it is written as S21 plus S17 by S19. This we need to find. This is what the question is. So for this, let us find the value of S17 and S21. So if I write this relation, if I put n is equal to 21 in the above relation, I can write this as S21 minus 7 times S20 minus S19 equal to 0. So if I take 19 on the other side, it can be written as S20 minus S7 times S20 is equal to S19. And if I write it down, S21 minus S20 7 times S20 by S19 will be equal to 1. Now I can do the same thing, but instead of putting n is equal to 21, let us put nothing but 8 is equal to 19. So if I put 19 here, what I get is S19 minus 7 times S18 minus S17 will be equal to 0. So now from here, if I want to find the value of S19, it can be written as 7 times S18 plus S17. Or we can write 7 times S18 plus S17 by S19 is equal to 1. See, now what we have done is, we have written two different manipulations. So what we want to do is, let us add both of these. So if I add both of these, I will be able to see what I need to do in the next step. So if I add them, it is this part. And you can see the denominator is same. So adding is also not very difficult. So we have add now both the results. The sum comes out to be 2. So this we have done. Now if you little bit manipulate this, you should be able to come up with the answer. So let us try and manipulate what is with us. So if I add them up, what we are getting is nothing but S21 would be there, that is the first term. S17 would be there, this also we want. And in the denominator, S19 would be there. But there will be some additional terms. Let us understand what additional terms would be there. There will be this 7 times S20 plus 7 times S18. And then you have nothing but this S19 is equal to 2. So now if somehow if I can find the value of this part, this second part, I will be able to get my answer. And if I closely observe this, I can find this value. Why? Because this is nothing but, if I take this 7 common, and I am just focusing on this part now. So if I just take this 7 common, in fact minus 7 common, it is nothing but S20 minus S18 by S19. Looks like Newton's theorem getting applied for S is equal to 20. So if I apply the same theorem for n is equal to 20, let us see what we are getting. So if I apply the same theorem for n is equal to 20, this will become S20 minus 7 times S19 minus S18 equal to 0. So if I take this S19 on the other side, and we can rewrite this statement as S20 minus S19 by S18 by S19, this will be equal to nothing but 7. So let us substitute this value. So the value of this is coming out to be minus 49. So if I rewrite the above statement, what we have is nothing but S21 plus S17 by S19. This is what we want. Minus 7 into 7 is equal to 2. So you can see that the value of this expression comes out to be 15. That is nothing but our answer. So you can see that it was not a linear application like earlier when we used to just apply it and we used to get the answer. Here we will have to manipulate it also after applying, and that makes this question really beautiful. Now if you think you have got the logic, then you can pause this video and try this question. Now how do we do this question? Again, the similar kind of logic is there. First we need to simplify, then apply the Newton's theorem. So if I factorize this first part, what I can do is from the first and third term, I can take P15 common. So what is left is P16 minus P15, and from the remaining two terms I can take P14 common. So it is nothing but P16 minus P15, and in the denominator what we have is nothing but P13, P14. So if I simplify this, what we are getting is P16 minus P15 into P15 minus P14. We can keep your P14 in the first part and P13 in the second part. Now why are we doing that? Because now if I apply Newton's theorem, what I am getting is Pn minus 1 minus 4 times Pn minus 2 will be equal to 0. So what we can do here is we can put the value first. Let us put the value of n is equal to nothing but 16. So P16 minus P15 minus 4 times P14 will be equal to 0. And if I simplify this, P16 minus P15 by P14, if I take P14 on the other side, becomes nothing but 4. So you can see that this term comes out to be 4. Similarly, the next one will also come out to be equal to 4. So answer to this question becomes 16. So first simplification, then application of Newton's theorem.
Now this 2024 question talks about alpha being greater than beta, and they have given us the Newton's theorem form but in negative sign. So what you can write from here in the first step is p raised to the power n minus root 2 p n minus 1 minus root 3 p n minus 2, this will be equal to 0. So once we have got this expression, life has become very simple. The reason behind that is, in the next part, that is next part. Now we can put different values of n here. So let us put the value of n is 12. If I put 12, this becomes 12 minus p11 minus root 3 p10, this will be equal to 0. And now if I put the value as nothing but 11, I have got one more relation, p11 minus root 2 p10 minus root 3 p9 is equal to 0. Now let us understand what is given in the question and break it down. So if I break down the question that is given to me, you can see that I can have all the terms involving 11. So I can take minus 11 common. So from the last term I can pick p12 up. From the second term I can put minus root 2 p11 up. And from the first term I can put up minus root 3 p10. And now if I look into the remaining terms, you can see that what I have left is nothing but 10 times p11, and from the first one it will become nothing but root 2 p10. This is what is given to us. Now if you clearly observe from the first relation that we have, the value of this expression that is given to us, this will be equal to 0. So what we are ultimately left with is nothing but 10 times p11 minus root 2 p10, and that is something that we are getting from here as well. So this will be equal to nothing but root 3 times p9. So answer to this question becomes 10 root 3 p9. So let us check the option. So you can see that A option matches. If I look into this next 2024 question, they are trying to mix up the idea of Newton's theorem with the idea of range of a polynomial, quadratic polynomial. So let us write down in very systematic steps. So if I apply Newton's theorem, I can write this as nothing but alpha n minus t square minus 5t plus 6 alpha n minus 1 plus alpha n minus 2 equal to 0. Once you have this, now in the second part I can put the value of n is nothing but 25 because that is the largest value that is present. And now if I simplify, I will get this into alpha 2024 plus alpha 2023 is equal to 0. Once I have got this value, now I can rewrite this statement as alpha 2025 plus alpha 2023. I can take the 2024 on the other side. This will become t square minus 5t plus 6 into alpha 2024. And if I take alpha 2024 on the left hand side, then you can see that we have got our question into place. And this is equal to t square minus 5t plus 6. So you can see that till this part we can solve and get using Newton's theorem. Now what they are saying is, what is the minimum value of this expression? Since this is a quadratic polynomial, the minimum value will always be minus d by 4a. So let us find the value of d. So that is b square minus 4ac by 4 times 1. And if I simplify, this comes out to be minus 1 by 4. That matches option B. Now this next one is based on the proof of Newton's theorem. So you can see that even if you multiply some coefficient here and here, the Newton's theorem result will not change. So if I want to apply Newton's theorem, it is Sn minus 1 minus Sn minus 2 is equal to 0. So all I need to do is substitute the value of n is nothing but 12. So you can see that S12 minus S11 minus S10 is equal to 0. That clearly matches option B.
Now let us start with the next type of problem, that is nature of roots. So for nature of roots, what you need to understand is, if we have ax square plus bx plus c equal to 0. So when we solved this, the value of x came out to be minus b plus minus root of b square minus 4ac by 2a. So now the nature of the roots will ultimately depend upon the root of the value that is inside the root, that is b square minus 4ac. So we call this as d or discriminant, and this is b square minus 4ac. So now let us say that these conditions happen, that your a, b and c are real. This is very important, and please do not forget this. And your d came out to be greater than 0, then in that scenario the roots are going to be real in nature. Now it happens that this a, b and c still belongs to real number. Then in that case your d came out to be equal to 0. In that scenario we are going to have real and equal roots. And in the last part, if I see, if we have a, b, c belongs to real number, and my d came out to be smaller than 0, in this case I am going to have imaginary roots. Now you can see that if I combine these two conditions, I get the condition for real roots. So for real roots, the condition is nothing but d needs to be greater than equal to 0. So this is the basic theory that we need to know, and very important again, I'm emphasizing once more, is this condition of ABC should be real. Otherwise, this becomes a question of complex number and there is a totally different technique to solve that question. Now let us see this question that was asked in 2020. In this question, what they're saying is, this expression has real roots. So if I simplify this, this becomes 2x square plus a minus 10x plus 33 by 2 minus 2a is equal to 0. So if it has real roots, then 2a minus 10, 33 by 2 minus 2a, this all needs to be real. This is first condition. And the second condition is your d needs to be greater than equal to 0. And the second condition will play a bigger part here. So if I put this, then a minus 10 whole square minus 4a c 33 by 2 minus 2a needs to be greater than or equal to 0. Now all we need to do is simplify and solve this inequality. So this becomes a square minus 20a plus 100 minus this will become 132 plus 16a is greater than equal to 0. This comes out to be a square minus 4a plus 32 is greater than equal to 0. It can be factorized as a minus 8 and a plus 4 greater than equal to 0. Now after this you can either apply baby curve method or method of signs to write the answer. So if I write the answers, what is going to happen is, there are two important values, minus 4 and 8. We can start from here and go like this. So these are positive, then negative, then positive values. So the answer of this question, since it is equal to, will also include this point, becomes a should belong to minus infinity to minus 4 union 8 to infinity. So if you look into this, the least positive value that is possible is nothing but 8. Hence 8 becomes our answer. So very simple question that you can solve and get the answer. Now in this question, if you are unable to understand this method that I have used here in order to write the solution, you can go and refer another video in the description, that is video on wavy curve method, that will be highly useful in solving such questions. Now you can see a very simple question was asked based on this idea in 2020. In this question, what we need to do is find the value of set A. Set A is those values of m for which this equation will have real roots. So if I write the condition of d greater than equal to 0, what I get is m plus 1 whole square minus 4a into c is greater than equal to 0. If I simplify it, is m square plus 2m plus 1 minus 4m minus 16 is greater than equal to 0. This becomes m square minus 2m minus 15 is greater than equal to 0. This can be factorized as m minus 5 into m plus 3 is greater than equal to 0. You can see from here, minus 3, 5, if I draw my wavy curve, this is the answer I am getting. And now going forward, I won't be drawing this, I will be directly writing the answer. So you can see the answer that we are getting is minus infinity to minus 3 union 5 to infinity. Now the question says that which of these options are not true. So if you check the options, you will figure out that D option is not true.
If I look into this next 2024 question, it talks about a triangle whose sides are A, B and C respectively, and they have given us a quadratic equation involving coefficients as nothing but the sides, and they want us to find all possible values of x such that the interval alpha in the, what they are saying is the set of all possible values of x is nothing but the interval alpha comma beta, and they want us to find the value of alpha square plus beta square. So let us try this question. In order to try this question, we can simplify this quadratic that is given to us. There are multiple ways to do it. Let us use this way, wherein we are going to now write this equation as a square x square minus 2abx plus b square. So what I have done is I have taken the first term of all the expression that are given to me. I am grouping them together, plus I am splitting the another one also. So b square x square minus 2bcx plus c square is equal to 0. So if I simplify the first one, it becomes ax minus b whole square. If I simplify the next one, it is bx minus c whole square equal to 0. So if I carefully observe now, what you can see is I have got the sum of two perfect square where all the numbers involved are nothing but real. So this can only happen when each of these perfect squares are equal to 0. So let us put both of them equal to 0. Once you have put them, you have got the value of x is b by a. You have also got the value of x is nothing but c by b. Now we can see that this can only happen when both of these values are equal. So b by a is equal to c by b. When we solve them, we get the condition of b square is equal to ac. And b is square equal to ac would mean the numbers a, b and c are in GP or geometric progression. So this was the contribution of the first part. Now if I move towards the second part of the question, we have to go into the triangle they are talking about. So now if I consider the ratio of b by a, so now what I can do is, since it is in GP, I can consider these three sides as nothing but a can be considered as nothing but a only, but b we can write as nothing but a into r, and c can be written as ar square. If I consider these values like this, then the advantage is now x here will become nothing but r from both the conditions. So what I need to find is basically what can be the range of r. Now if I look from a triangle's point of view, one side is a, another will become ar, and another will become ar square. So now we know that from triangle equality that any side should be smaller than the sum of other two sides. So let us apply that idea. If I do that, I have put the biggest side on the left hand side and two smaller sides on the right hand side to get the extreme scenario. So if I now simplify, what I am getting is r square minus r minus 1 is smaller than 0. If I check this out, the value of r from here, if you solve, would become 1 plus minus root of b square minus 4ac by 2a. So answer comes out to be 1 plus minus root 5 divided by 2. Once we have done this, in the third part, now we can see that you have already got the range, you have got the value of alpha beta. So in the third part, we will have to find the value of alpha square plus beta square. Now this expression can be in turn written as alpha plus beta whole square minus 2 alpha beta. So alpha plus beta would be nothing but the sum of the roots of this equation that was with us. So that would become nothing but minus b by a, that becomes 1. And then alpha into beta would become nothing but minus 1 from here. So 2 into minus 1. So if I put these values, you can see the answer comes out to be 1 plus 2, that is nothing but 3. Now what they have also done is they have multiplied this expression by 12. So in the fourth step, my final answer comes out to be 3 into 12, that is nothing but 36.
Now let us look into this next problem type that talks about rational and integral roots. So the condition for rational root is very simple. It says that if we have x is equal to minus b plus minus root of b square minus 4ac by 2a, then the condition is a, b, c, if this belongs to q, that is rational numbers, then in that scenario, if this root sign does not comes, that means this d is a perfect square, then rational roots will occur. This is the condition. Now once you have got this condition, what if we add one more additional condition into this, that is this b is a multiple of 2a, and this root of b square minus 4ac, this is also a multiple of 2a. In that scenario, integral roots will also occur. Now let us see what kind of questions JEE has made on this idea. So if I take into this question that came into 2019, it talks about all the possible positive values of alpha for which this equation is going to have rational roots. So now here, first thing that we are going to check is nothing but the perfect square condition. So let us find d. D is nothing but 11 square minus 4a alpha. So if I write it down, it is 121 minus 24 alpha. So if we can clearly see here that 6, 11 and alpha needs to be rational numbers. So this need to be rational number. That is the first thing. And these are the two conditions that we have. So if I look into this, now let us take what are the possible positive values of alpha there can be there. So let us start with alpha is equal to 1. So what we will have is 121 minus 24. This becomes 97 and also not a perfect square. If I take alpha is equal to 2, what I get is 121 minus 24 into 2, and that would be nothing but 121 minus 48, and if I subtract 40 from this, this becomes 81. 81 minus 4, 81 minus 8 would be nothing but 73. So again, not a perfect square. But if I take alpha is equal to 3, let us see what happens. So it becomes 121 minus 24 into 3. So again, if I subtract 24 from the above statement, it becomes 49, which is a perfect square. And again, if I take alpha is equal to 4, it is 121 minus 24 into 4. And the last value could be alpha is equal to 5. If I take this, it is 121 minus 24 into 5. And corresponding to this, I get 1. Again, a perfect square. So there are three possible values of alpha. Positive values of alpha: 1, 4, 3, and 5, corresponding to which rational roots will occur. Hence, the answer to this question becomes option D.
Now, in this next 2024 question says that this equation has integral roots. They have been given as integral roots, and it is given that if I write the product of those roots, so what they have given us is nothing but the sum of the roots. It is nothing but 70, and then the product of the roots is nothing but lambda. So what they are saying is the roots are integral, that is one condition, and the second thing is if you find the value of alpha into beta, lambda, this lambda by 2 and lambda by 3, this cannot be a natural number. So now if you understand this question, now what they are saying is you have to first figure out the minimum possible value of lambda and then substitute the value of lambda in the given expression to get the answer. So now let us think about cases. So if I want to get 70 and if I start assigning minimum values of alpha and beta, let us see what are the possibilities that are there. So I can take 1 is 1, then 69. Now this would be the minimum multiplication, but then 69 is divisible by 3. So this is not possible. 2, 68, 2 comes. The multiplication will be a multiple of 2. Then if I take 367, the multiplication will be a multiple of 3. Then if I take 4, 66, still it will be a multiple of 2. 565. Now this is the first condition and the smallest value when lambda is not becoming a multiple of 2 or 3. So we have got the value of alpha beta. Now let us move forward. So in the third step, now the value of lambda will become nothing but 5 into 65. Value of alpha will be equal to 5 and beta will be equal to 65. We can substitute all of these values in the expression that is given to us, and if I do so, the value of expression in the fourth step comes out to be 60.
Now, if I look into this next problem type, it talks about range of quadratic polynomial. So, if I take a quadratic polynomial ax square plus bx plus c, this quadratic polynomial can have two types of ranges. So, if a is greater than 0, that means the graph of this polynomial will be something like this. So, the bottommost point, this point, comes at minus b by 2a and the value is minus d by 4a. So, if a is greater than 0, in that scenario, the range becomes minus d by 4a to infinity. And another scenario can be when a is smaller than 0. In this case, this kind of graph will come. The value of the point remains same, minus b by 2a to minus d by 4a. But since the graph is bottom down, here the answer would be minus infinity to minus d by 4a. So these are two very simple results. If a student understands and remembers, he will be able to solve all such questions. So if I look into this first question that came into 2022, in this question, what they are saying is, if I take the roots of this equation as a and b, so they want us to minimize the value of a square plus b square. So I can write a square plus b square using relation between roots and coefficients. This we have already done. A plus b whole square minus 2ab. So once I write it down, the value of a plus b can be written as alpha minus 6 by 3 whole square, and ab can be written as alpha plus 3 by 3, And if I simplify it, it becomes alpha square minus 12 alpha plus 36 minus 6 alpha minus 18 by nothing but 9. So you can see that this becomes a quadratic equation, which is nothing but alpha square minus 18 alpha plus 18 by 9. Now we know that the minimum value of a quadratic is minus d by 4 and comes at minus b by 2a. So the minimum value of this expression will come when alpha will be equal to minus b. So minus of minus 18 by 2a. So you can see the value of this will come at alpha equal to 9. Now they have given one additional condition that along with this, the roots of this equation also needs to be real. So they want two real roots. So let us apply the condition for two real roots. So this was the first part. Let us do the second part. So if I do that, my d needs to be greater than equal to 0. So my d here becomes nothing but alpha minus 6 whole square minus 4 into 3 into alpha plus 3. Now let us see whether this is real or not at this value. So if I put it here, it becomes 9 minus 6 whole square minus 4 into 3 into 12. You can clearly see that this is smaller than 0. So the minimum value of a square plus b square comes at alpha is equal to 9. But if I put that value in the value of d, it comes out to be negative. So when alpha becomes 9, the roots become non-real. Hence, there is no such value of alpha for which the minimum value will come. Hence, A option, empty set, becomes the right answer. Now, let us look into type 7 problem, that is quadratic inequality. So, a very important result in this case is, see, when we are dealing with quadratic inequalities, we will conceptualize it using graphs. So, you need to first understand the graphs of quadratic polynomial. So, if I plot a quadratic polynomial, there are 6 types of graphs that are possible. The first one that are above, then the one that touches, then the one that cuts, and then all of these cases when we are looking into graphs which are concave downwards. So if you do the first case, the first three cases will arrive from here to here when a is greater than 0. The bottom cases will arrive when a is smaller than 0. So when it is above, d is smaller than 0. When it is touching, d is equal to 0, and when it cuts, d is greater than 0. The same conditions are here as well. D greater than 0, d equal to 0, and d smaller than 0. If you understand this, and if I give you a condition like ax square plus bx plus c is greater than 0, you can see that now this can only occur, and this is for all the real values of r. So it can only occur in this first case. So the condition corresponding to this should be a is greater than 0 and d is smaller than 0. This is very important result. It looks counter logic because most of the times when we are talking about real roots, we are putting d greater than equal to 0. But here you can see the condition reverses and the reason lies in the graph. Similarly, if I write a condition and say that ax square plus bx plus c is smaller than 0, then you can see that this last case will occur. So in this case, the condition is a is negative and d is also negative. Again, you need to remember these two basic conditions to solve any kind of questions based on quadratic inequalities. Now let us see what kind of questions are asked on this idea. So let us start with this first question that was asked in 2021. So what we are saying is integral value of k for which this inequality is valid for all real values. So you can see that the value of a here is nothing but 1 and it is already greater than 0. So do not need to check this first condition, but the second condition, that is d, needs to be smaller than 0. This we will have to check. So if I do so, this becomes b square, that is 2 into 3k minus 1 whole square minus 4a, that is 1, and c, that is 8k square minus 7. This would be smaller than 0. If I simplify this, it is 4 into 3k minus 1 whole square minus 4 into 8k square minus 7, and this is smaller than 0. If I simplify this, this 4 will go away and I can write this as 9k square minus 6k plus 1 minus 8k square plus 7 is smaller than 0. If I simplify, it is k square minus 6k plus 8 is smaller than 0, and I can write this as k minus 4 into k plus k minus 2. And if I simplify, I will get my answer. So you can again see that the condition corresponding to this would be nothing but k needs to lie between 2 and 4. So what they are asking is, what are the integral values of k? So the possible value of k can only be equal to 3. Hence, your option 1 becomes correct. Now we can see that similar kind of question also came in 2019. Again, they are asking that this is always positive for all real values. So again, the condition is, first condition is A. So now we can see that here the value of A needs to be greater than 0. This is the first thing. The second condition is D if I write. It needs to be smaller than 0. So D if I write, it is nothing but minus 2 into 1 plus 3m whole square minus 4a, that is 1 plus 2m, into c, that is 4 times 1 plus m. This needs to be smaller than 0. And 4 I can cancel out. So what I am getting is 9m square plus 6m plus 1 minus 4 times, this we can write as 2m square plus m plus 2m plus 1. This would be smaller than 0. So this becomes 9m square plus 6m plus 1 minus 8m square minus 12m minus 4 is smaller than 0. If you simplify this, this becomes m square, and again this becomes 6m, and if this becomes minus 3 is smaller than 0. So what we need to do is we need to simplify this. So if I simplify this, what am I getting is, in this quadratic, if I find the roots, m will be equal to 6 plus minus root of b square minus 4ac by 2a. So if I simplify, the two values of m that I am getting is 6 plus minus root of 36 plus 12 would be equal to 48 and by 2. So 2 if I cancel out, this becomes 3 and this becomes nothing but 12. So this is 3 plus minus root 12. So what we can see from here, if I plot all of these on number line, corresponding to 1, the solution was m is greater than minus 1 by 2. So the first one says that it is greater than minus 1 by 2. If I look into the second part, what they are saying is, your answer needs to lie between 3 minus root 12. Now see, root 12 is somewhere between 3 and 4. So 3 minus root 12 would be somewhere here, and 3 plus root 12 would be somewhere here. So this value, so root 12, so root of 9 is nothing but 3. So the root 12 is between 3 and 4. So 3 minus root 12 will be somewhere between minus 1 and 0. And this value, so 0 will come here, and 3 plus root 12 would be nothing but 6 to 7. So this value is between 6 to 7. So what you can see is 6 will come here, 7 will come here, minus 1 will come here. So if I look into all the integers that are there, so 0 is there, then 1 would be there, 2, 3, like this. So what are the possible integers? The possible integers, if I write them down, the values would be 0, 1, 2, 3, 4, 5 and 6. You can see that there are total 7 integers that are possible, hence option C becomes correct.
In this next 2024 question talks about the set S of value A says that this expression is smaller than equal to 0, smaller than 0. Now in such expression, the first thing that you should do is check out the value of D for the denominator. So if we look into the denominator part, b square minus 4ac, so 8 square minus 4ac, this will be smaller than 0. That would mean for the bottom expression, a is greater than 0, the leading coefficient is positive and d is smaller than 0. That would mean the graph of this quadratic, x square minus 8x plus 32, will always be about x-axis and hence it is always positive. So in the next step, the sign of the expression will be determined by the numerator only. So what I need to ultimately solve is ax square plus 2 times a plus 1x plus 9a plus 4. This should be smaller than 0. Now, in order to solve this question, there are two very important steps. We always want this to happen. So now, irrespective of the values of x, so this would mean the graph needs to be below x-axis. This condition is there if the leading coefficient here needs to be smaller than 0 and the discriminant should also be smaller than 0. So this condition I have already written. For D, if I write, then 2a plus 1 whole square minus 4a and C 9a plus 4, this should be smaller than 0. So a square plus 2a plus 1 minus 9a square and minus 4a should be smaller than 0. If I simplify, this becomes minus 8a square minus 2a plus 1 is smaller than 0. So this is the expression in a that we are getting. So if I simplify this, I will have 8a square plus 2a minus 1, this will be greater than 0. Now what they are asking is set of the positive values of a for which, so number of elements in set is as be the set of positive integral values of a. Now if I solve this, a will be equal to minus 2 plus minus root of b square minus 4ac. So that would become 4 minus 4 into 8 by 2 times. So if I divide by 2, this 4 will go away. So what we are getting is minus 1 plus minus 9 will become 3 by 8. So you can see that there are two extreme values. One extreme value, if I draw the wavy curve, would be nothing but minus 4 by minus 8. This will become minus 1 by 2. And if I take the plus sign, it is 3 minus 1, 2. 2 divided by 8 is nothing but 1 by 4. So we are talking about values greater than this and smaller than this. Now we know that a needs to be negative. So another condition we have is this condition. If I look into this, this means this is saying this a needs to be negative. So you can see that set of positive integral values of a. So this cannot have a positive integral value. The answer of this question becomes a, that is 0.
Now the next problem type is location of roots. So first let us try and understand some basic theory on location of roots and then jump on to the problems. So there are three basic concepts and 2-3 more ideas that you need to understand in any case of or condition of location of roots. The first is, if you are talking about one constant, so this is the first case. So the one constant can lie smaller than both the roots. So now corresponding to this, both the cases are possible. So k is smaller than both the roots. So what are the conditions that you can write? The first condition is, if I put this into the polynomial, then f of k would be greater than 0. Here f of k would be smaller than 0. And then the value of k would be less than this central point. This central point is minus b by 2a. We have done this earlier. So your k needs to be smaller than minus b by 2a. The same condition will come in here also, because these are the two types of curves that are possible. So if you write both of these in a singular condition, you can write that condition as a into f of k. A is nothing but the leading coefficient, needs to be greater than 0. This is the first condition, and another condition is k needs to be smaller than minus b by 2a. So using these two conditions, you can do a question where both the roots are, the number is smaller than both the roots. Another condition that can be there is if our roots, the k lies between both the roots. And now I am only going to take one case and put this a here in order to generalize it. So if it is lying between, I only need to write one condition. That condition is, if I take the value of this function at k, it needs to be negative, because here if you look into the value of the function, it is negative. So a into f of k is smaller than 0. This is the only condition. The third part will come when both k is greater than both the roots. So here also you will write a into f of k is greater than 0. But the other condition will change. K will now be greater than minus b by 2. So the only difference between this and the first case is the sign of greater than and smaller than. So again, we are getting two conditions. So these are the three important conditions when we are dealing with one constant. Now let us say that we are dealing with two constants. So the logic would be, the first case would be those both k1 and k2 are smaller than both the roots. If this happens, and it is understood here that k1 is smaller than k2, this is given to you. Because k1 and k2 are fundamentally constants. So now if you again write the condition, then for k1 I can write a into f of k1 is greater than 0. Also a into f of k2 will be greater than 0. Also your k2 will be smaller than minus b by 2. So this becomes a required condition. Now another case would be when one root k1, one constant k1 is here, another is between the roots. So if you now write the condition, and obviously one more condition that we forgot, we should write here is d needs to be greater than or equal to 0. In the earlier cases also, we need to consider this basic condition regarding discriminant. Discriminant needs to be greater than or equal to 0. Discriminant needs to be, here we do not need to write it, but in the next one I will have to write d is greater than or equal to 0. This is the condition for real roots that we need to write. Now in this case, the next case that we are doing, the conditions will become a into f of k1, and this is greater than 0 because here the value of the graph is above x-axis. The next will become a into f of k2 is smaller than 0. Since this will only occur when both the roots are real, so we do not need to take the condition for d here in this case. Also, since we want this to be smaller than the root, so one more condition I can write, k1 needs to be smaller than minus b by 2. So this completes the set. Now, if I want to write another case in which k1 is on one side, k2 is on the other side of both the equations, now you can write a into f of k1 is greater than 0, a into f of k2 is greater than 0, minus b by 2a, this lies between k1 and k2. And also we need to write the discriminant condition, so d needs to be greater than or equal to 0. Now, this condition is for real roots. You can see that using this mechanism, you can write all the possible cases. One more case is possible when both the constants are now between the roots. So now you can write a into f of k1. This is smaller than 0, and a into f of k2 again is smaller than 0. Since we are putting them between the roots, then in that situation d is not required like earlier. So we do not need to take the condition for d. Eighth one, if you want to write, now I can put k1 here and take k2 on the other side. So again I can write a into f of k1 is smaller than 0. Since I have written this condition, d will not be required, and a into f of k2 now is greater than 0. Since k2 is on the other side, we need to write this condition, k2 needs to be greater than minus b by 2a. And the last case, that is the ninth case, happens, and you can also make up these cases when k1 and k2 are both on the same side here. So if this happens, then a into f of k1 would be nothing but greater than 0. A into f of k2 will be nothing but greater than 0. Your another condition would be for the location, so k1 needs to be greater than minus b by 2a. And obviously we will need a condition of discriminant, in this case d is greater than or equal to 0. So if you use these 9 cases, usually you will get a JEE question in either of these 9 cases. If it is simpler, it will be in the first 3, a little bit complicated than in the next 6 cases. Now let us see what kind of question JEE has based on this idea. Now in this case, the question is that if I draw the graph, obviously the kind of polynomial that is given to us, or the equation that is given to us, a is greater than 0. So I only need to draw this graph, something like this. Now what they are saying is, number of integral values of k for which one root of this equation lies between 1, 2 and another root lies between 2, 3. So 1 should be here, 2 should be here, and 3 should be here. Something like this. So now they have introduced 3 constants here, but I can build my logic based on whatever we did earlier. So now what I can say is, here let us write the condition for constants first. So f of 1 would be greater than 0. F of 2 will be smaller than 0. And f of 3 would be greater than 0. Since f of 2 is smaller than 0, this condition we have written, we do not need to write any discriminant condition. And if I think logically, now my minus b by 2a should lie between 1 and 3. This should happen. So this many conditions should be enough to give us an answer. So let us try and solve these conditions. So if I solve my first condition, let us see what I get. So f of 1, if I put, it is 2 minus 8 plus k, this needs to be greater than 0. So you can see that k needs to be greater than 6. This is what we are getting from first condition. If I solve the second condition, f of 2, if I put, so it is 2 into 4 minus 8 into 2 plus k needs to be smaller than 0. If I simplify, it is 8 minus 16 plus k is smaller than 0. K should be smaller than 8. Similarly, if I solve the third condition that is given to us, the solution of the third condition becomes 2 into 9 minus 8 into 3 plus k needs to be greater than 0. This is my third condition. So it becomes 18 minus 24 plus k needs to be greater than 0. So k should be greater than 6, and this is something similar to first condition only. There was one more condition that we have written here. Let us also try and solve this last or the fourth condition. So that says that minus b by 2a. So this will become 8 by 2 into 2. This is nothing but 2, and this lies between 1 and 3. So this condition is universally true. So if I try and take the intersection of all the things that we are getting on the same number line, the first condition says that it needs to be greater than 6. So let us plot 6. The another condition says that it needs to be smaller than 8. Let us also write 8. And then the last condition says that all the values are fine. So I need to take that area where all the three things are. So this is my possible answer, value of k. So k should belong to 6 to 8. This is what we are getting. Now here what they want is not this interval, but integral values of k in this interval. So there is only one integral value, that is k is equal to 7. Only one value is there, so option C becomes correct. Now this 2019 question is slightly simple. It talks about quadratic equation whose roots are real and distinct. So this is the first thing, something like this. So when they are saying real and distinct, in mathematical terms, it becomes a condition d needs to be greater than or equal to 0. Real and distinct, so not even equal to, just d is greater than 0. In the second part, what they are saying is, and both the roots of this quadratic equation lie between 1, 5. So 1 need to be on this side and 5 need to be on this side. If you do this, another condition that we can write is f of 1 needs to be greater than 0. And I'm not writing 1 because here the value of a is 1. So a into f of 1 is not required. Another condition would be f of 5 also needs to be positive. D condition we have already written. And fourth would be minus b by 2a needs to lie between 1 and 5. So now we need to write the answer for all of these four conditions, take intersection and get to the answer. So if I solve my first condition, because after this there is just calculation. So if I just solve my first condition, that is d. So it becomes b square minus 4 ac. This needs to be greater than 0. So you can see from here, the solutions that we are going to get, m will lie between, this will become m minus 4 and m plus 4 is greater than 0. So from this first condition, what we are getting is m belongs to minus infinity to minus 4 union 4 to infinity. This is the first part. If I write the answer to my second condition, so what we need to do is just put 1 here. So 1 minus m plus 4 needs to be greater than 0. So if I solve this condition, this becomes 5 minus m is greater than 0, or m is actually smaller than 5. And if I write my third condition, let us see what the third condition says here. So my third condition is saying that f of 5, if I put 5 here, in the quadratic it becomes 25 minus 5m plus 4. This will also be greater than 0. So if I simplify this, this is nothing but m will be smaller than 29 by 5. This is another condition that we are getting. And if I look into my fourth part, I will have to find the value of minus b by 2a. And if I do so, then minus b by 2a becomes nothing but m by 2. And the value of m by 2 needs to lie between nothing but 1 and 5. Your value of m also lies between 2 and 10. Now let us draw all of these on a single number line and check what are the possible values that we are getting to be correct. So if I draw a number line like this, what am I getting from the first condition is it needs to be smaller than -4 or greater than 4. So we are getting these values from the condition 1. Look into condition 2, it talks about value of m smaller than 5. So if I draw 5 here and take values smaller than 5, my condition 2 will become true. In the third part, what they're saying is m needs to be smaller than 29 by 5. So 29 by 5 is actually slightly greater than 5. So again, it is talking about the similar kind of behavior. And the last part says that we need to be between 2. And then this talks about between 2. So 2 will be somewhere here. And 10 would be somewhere here. So if I draw this last one also, these are the values that we are talking about. So now we want those areas where all the 4 lines would be there. And if you observe from this diagram, that part would be nothing but this part. So our answer becomes nothing but 4 to 5. This becomes my answer. So my option A will become or come out to be true. Now the next problem type is based on common roots. So if you have two quadratic equation like a1x square plus b1x plus c1 equal to 0 and another one is a2x square plus b2x plus c2 is equal to 0. So now we have transition from one quadratic to two quadratic. So they can have two conditions here. Either they can have both roots common or they can have one root, at least one root common. So we have two different scenarios. See, at least word is important because whatever condition we will be writing will also be true for two roots common. That is the reason we need to take this word at least very carefully. So if both the roots are common, the condition is that a1 by a2 will be equal to b1 by b2 will be equal to c1 by c2. This question will not be directly asked. In all such questions, they will give us either the first case, the quadratic will be given in such a manner that if you figure out its discriminant, either it will give you an irrational roots. So when one irrational root is equal, by the concept of irrational roots, both will become same. Or it will be asked in the context when d is smaller than 0 and imaginary roots. Again, if one imaginary root is same, the another will also become same. So both root becomes equal. So in this is how this question is asked. And in case of at least one real root common, what we are going to do is we are going to apply cross multiplication. Let us say that x is the common root. So if I apply cross multiplication, x square by b1 c2 minus b2 c1 would be equal to minus x by a1 c2 minus a2 c1 and is equal to nothing but 1 by a1 b2 minus a2 b1. So this becomes the condition, and from here if you take these two and these two, we can eliminate the value of x or find the value of x, either of the ways. If I find the value of x from the first one, it is nothing but minus times b1 c2 minus b2 c1 by a1 c2 minus a2 c1. And from the next one, if I find the value of x, it is nothing but minus times a1 c2 minus a2 c1 by a1 b2 minus a2 b1. Now if I equate both of these conditions, I get the condition of at least one common root. At least word is again very important. Sometimes there will be question that talks about exactly one common root. Then we need to take the first condition and remove those answers from the second condition. And then that is how we can get the answer. Now let us see what kind of questions are based on this idea. Now again, in this question, they are talking about at least one common root. Also, they are saying that find the corresponding value of a, and from that value of a, you find the value of beta. So let us write it down. So if you are talking about that condition, we can write both of these equations down. And once we have written it down, what you will observe here is we need to apply the cross multiplication technique. So x square by 25a plus a would be equal to minus x by minus 5 minus 1 and would be equal to nothing but 1 by minus a plus 5a. So if you simplify this out, what we are going to get from the first condition is x square by 26a would be equal to minus x by minus 6 would be equal to x by 6. And the last condition will become 1 by 4a. So if I simplify these two conditions, find two values of x and equate, let us see what we get. So from the first two conditions, the value of x comes out to be 26a by 6. That is nothing but 13a by 3. From the next two, what I get is x is nothing but 3 by 2a. If I equate both of these, I get my condition of at least one common root. So 13a by 3 would be equal to 3a by 2a. You can see that a square comes out to be equal to 9 by 26, or the value of a comes out to be nothing but 3 by root 26. If I compare it with 3 by root 2a, root 2 beta, the value of beta comes out to be 13, which is nothing but our answer. So it is a very straightforward question based on the core conditions of common roots. Now if I look into this first question that was asked in 2019, in this question, what they are talking about, they have mixed the concept of APGP or sequence series with this common root concept. So alpha, beta, gamma are nothing but three consecutive terms of a GP. So if I assume alpha to be A, my beta becomes nothing but AR and my gamma becomes nothing but AR square. This is what is given to us. Now if I put this value in this first quadratic, it becomes AX square plus 2ARX, then AR square is equal to 0. So a can be removed. What we are getting is x square plus 2xr plus r square equal to 0. So x plus r whole square is equal to 0. The value of x becomes nothing but minus r. This is what we are getting. Now if I look into the other equation and if I satisfy this value, what we are getting is r square minus r minus 1 equal to 0. So the value of r square is nothing but r plus 1. Now this is an important condition because they are not asking the value of alpha beta, alpha times beta plus gamma. So alpha becomes a, beta becomes AR and gamma becomes AR square. So if I take it common, so a into AR, if I take common, it becomes 1 plus r, and the value of 1 plus r we can substitute from above. This becomes AR and then AR square. So the first thing can be written as beta, another one as gamma. So my option comes out to be D. If I look into this next question that came into 2022, it looks like a question of common root because they are talking about first equation whose roots are nothing but alpha and beta, and then they're talking about another equation whose roots are nothing but alpha and gamma. So you can see that it talks about one root that is being common. But if I use my orthodox technique of finding the condition and from there getting the value of lambda, it will become very long. So I cannot use my traditional technique. And then the question is very simple. What they are asking is nothing but the value of alpha plus beta plus gamma. So see, beta plus gamma they have already given. So this part is taken care of. There is no issue. But if you find this part, it is equal to 4 lambda. So in order to get this, you will want the value of lambda. And if you use your traditional technique, it becomes extremely long. So what should be the shortcut involved in this question to get the answer faster? That we need to understand and learn. So in this question, what we can do is we can find the value of alpha beta. This is my first step. If I find alpha beta, it will be nothing but 5. So if I just find the value of alpha plus gamma from the next equation, what I have is nothing but 3 root 2 plus 2 root 3. This is given in equation 2. Also, what is given in the question is the value of beta plus gamma. If I write this equation, this is nothing but 3 root 2. So if I subtract both the equation, what I get is the value of alpha minus beta. That is nothing but 2 root 3. So now I have the value of alpha beta and I have the value of alpha minus beta. I can solve these two equations to get the value of alpha and beta. So I can put the value of beta from here. So it becomes 5 by alpha will be equal to 2 root 3. And then if I solve this, it is alpha square minus 5 is equal to 2 root 3 alpha or alpha square minus 2 root 3 alpha minus 5 is equal to 0. So alpha becomes nothing but 2 root 3 plus minus root of b square minus 4ac. So if I write the value of b square, it will be nothing but 4 into 3 minus 4ac by 2a. So if I write this and simplify this, this is nothing but 2 root 3 plus minus, this will become 4 into 3 plus 4 into 5 by 2. If I divide by 2, this 4 will get cancelled out. So what we have is nothing but root 3 plus minus root 8, that is nothing but 2 root 2. I am considering plus value here. We can also take minus. There is no problem with that. So if I consider the plus value in the second part, what I can do here is using this value of alpha, that is nothing but 2 root 2 plus root 3. If I put it here, alpha beta is equal to 5. So what we have is beta is nothing but 5 by alpha. If I put this here, and if I rationalize, it is 2 root 2 minus root 3. And this becomes 2 root 2 minus root 3. So if I simplify this, this comes out to be 2 root 2 minus root 3. Now we have got the value of alpha and we have got the value of beta. So let us go back to the question once more. In this question, what we want is the value of alpha plus beta plus gamma. So in the third part, if I try and solve it, so let us substitute the value in the third part. So what we want is alpha plus beta. If I add these two, the earlier two values, it becomes 4 root 2. And beta plus gamma is again given as 3 root 2. So if I add both of these, I get the value of alpha plus beta plus gamma. And what I want is whole square. So this would be nothing but 7 root 2 whole square. And if you simplify this, this comes out to be 98. So you need to be thinking little bit out of the box in order to get the solution faster. Now again, we have to use the similar kind of approach that we used in the last question, in 2023 question also. So again, they are talking about two roots alpha and beta for this first equation. So if I write the value of alpha plus beta, it would be nothing but 31 by 14. And if I want to write the value of alpha into beta, it is going to be nothing but 3 lambda by 14. Similarly, for the next equation, the roots are alpha and gamma. So if I write the value of alpha plus gamma, it is nothing but 53 by 35. And if I write the value of alpha times gamma, it is nothing but 4 lambda by 35. So this is the first thing that we need to notice. See, now one way to solve this question is to write the condition of common roots. From there, find the value of lambda. Then use that lambda to find the value of 3 alpha by beta, 4 alpha by gamma, and then write the equation. So if you look into the original flow of the question, it will go something like this. Find the value of lambda using condition of common roots. Get the value of alpha, beta and gamma from there. Then find the value of 3 alpha by beta and 4 alpha by gamma. Get these two values and then form equation using these roots. So this is the original flow of the question, but see, this is going to take a lot of time and you do not have that kind of time in an exam to solve such kind of questions. So what we need to do is we need a shortcut. So what you can do is you can think smartly. The smart process would be, if alpha is the root of first equation, we can satisfy this alpha into it. So we can write 4 alpha square minus 31 alpha plus 3 lambda is equal to 0. And here if I divide by 3, this becomes 14 by 3 alpha square minus 31 by 3 alpha plus lambda equal to 0. And if I do the same process for the next equation, it will become 35 by 4 alpha square minus 53 by 4 alpha plus lambda equal to 0. Now what we can do is we can eliminate this lambda, solve to get the value of alpha. So if I do that, what am I getting is 35 by 4 minus 14 by 3 into alpha square plus minus 53 by 4 minus plus 31 by 3 alpha is equal to 0. So now clearly we know that alpha cannot be equal to 0 because they have given lambda is not equal to 0. If alpha becomes 0, then lambda becomes 0. So we cannot take alpha is equal to 0. We can cancel this value out. So the value of alpha that we are getting from here comes out to be 35 into 3. 5 into 3, 15, 1. So 105 minus 4 into 4, 16 and 1, 56 by 12 into alpha, and this we can write this as nothing but 159 minus 159 plus 124 by 12 is equal to 0. So if I solve for that, this becomes nothing but 49 times alpha plus, and if I subtract this would be nothing but 5 3 minus 35 is equal to 0. So alpha becomes nothing but 35 by 49, and if you simplify this would be nothing but, if I divide by 7, it is 5 by 7. This is the value of alpha that we are getting. Once you have got the value of alpha, we can revisit our earlier statements and write our third step. So our third step would be to get the value of beta from here and gamma from here, because once we found beta and gamma, then we have got our roots. Once you have got the roots, we can write the equation. So now if I want to find the value of beta, it comes out to be 31 by 14 minus alpha, that was nothing but 5 by 7. So this becomes 21 by 14, and that would be nothing but, if I again divide by 7, this becomes 3 by 2. Similarly, if I find the value of gamma from here, it is nothing but 53 by 35 minus 5 by 7. If I do so, it is 53 minus 25 by 35. And if I do this, so it would be nothing but 28 by 35. And if I simplify this, divide by 7, so 4 by 5 we will get. So this is what we are getting. So now once you have found the value of beta and gamma, you can see that you can get to the step number 4. Our step number 4 is to get the value of 3 alpha by beta and 4 alpha by gamma. So if I write this value, so 3 times alpha was nothing but 5 by 7 by beta. Beta when we solved came out to be 3 by 2. So if I divide this, what I'm getting is nothing but 10 by 7. So this is my first root. And my another root will be nothing but 4 times alpha, that is 5 by 7, by gamma, that came out to be 4 by 5. So again I can divide this, and it comes out to be nothing but 25 by 7. Now I have got both the roots, so I can form my equation. If I obtain the product of the roots, it is going to be 250 by 49. So plus 250 by 49 is coming in option 1, 2 and 3. 4 cannot be my answer. And if you sum it up, it comes out to be nothing but 35 by 7. And that is nothing but, from here if you simplify this, you are getting the same kind of answer. So answer B becomes our correct answer. Now this 2022 is a very interesting question. In this question, what they are saying is these two equations have a common root. And now if you look into this equation, it looks like a very innocent looking equation. You can solve this also. It is x plus 4 into x minus 2 equal to 0. So there are two values of x that we are getting, minus 4 and 2. So when we are talking about one root common, it would be either minus 4 or 2. So it looks like a very simple question. And now what they're saying is you find the value of this relation between P, Q and R. Now one innocent looking suggestion is given here, that is this, because see, when I put 4 and 2, I will get different values. Now let us first try and solve this equation. If you solve this equation, what we'll note is the value of D in this one. So if you find the value of D of this first equation, it is nothing but 4 Q square P plus R whole square minus 4 P square plus Q square into Q square plus R square. Now what is the importance of this statement? You will see or understand in a minute. So once I simplify this, 4 can be taken common. This becomes Q square P square plus Q square R square plus 2 P R Q square. And then from the other statement, we can write P square Q square minus P square R square minus Q raised to the power 4 minus Q square R square. If we do this, we can see that P square Q square will get cancelled out. Q square R square will also get cancelled out. And if I take minus sign common, what we are getting is nothing but Q raised to the power 4 plus P square R square minus 2 PRQ square. So this is nothing but a perfect square. So this is nothing but Q square minus PR whole square. So what we can see from here, it is a perfect square. So this quantity is positive, and this is also positive. But because of this negative sign, it can become negative and it will have no real roots then. So if roots need to be common, they need to be real, because other equation has both the roots as real roots. So this can only happen when your Q square minus PR become equal to 0. And that would mean P, Q and R are nothing in GP or geometric progression. So if I take P as capital A, Q as capital AR, my small r will become nothing but A capital R whole square. So this is what we are getting. And now the first statement that we have highlighted becomes significant, because what they are saying is not all of them are going to have same sign. That would mean R cannot be positive. That would mean R need to be smaller than 0. Now this will help us shortlist two different answers we are going to see in a minute. So once we have got this, now let us look into this equation that they have given us. So in the second part of this question, this was the first part. Second part of this equation, if I substitute the value, this becomes a square r raised to the power 4 plus a square, sorry, r square and then r raised to the power 4. And in the denominator, what we have is nothing but a square. So if I simplify this, what am I getting is nothing but r square plus r raised to the power 4. Now, this is what we are getting. Now see, what we need to find this value is nothing but the value of r, and we know that r needs to be smaller than 0. So now how to find the value of r? That is our third part. So now if I take either of these values, so let us take minus 4 first and put in this equation. So even that is not required, because x we can have solved, d has come out to be 0. And so the value of x will become nothing but 2 times q times p plus r by 2 times p square q square. So this is nothing but the value of x. And if we solve, because the d came out to be 0, we have used the formula minus b plus minus root of b square minus 4ac by 2a. This 2 will get cancelled out. And if I simplify this by putting the value q as nothing but ar, p as nothing but a, and this is nothing but ar square by a square plus a square r square. We can simplify this. A square gets cancelled out, and what we are getting is r times 1 plus r square by 1 plus r square. So this gets cancelled out, x is nothing but r. So now if I look into this equation, x can have two possible values. So if I take x is equal to minus 4, and r will also become minus 4 and hence negative. And if I take x equal to 2, my r will also become 2 and hence positive. So this value we cannot accept, because in the question they have categorically said that they do not have same sign. That is the reason r becomes minus 4. And now in the fourth step, we can satisfy and find the value. So what is the value of the expression? It was r square plus r raised to the power 4. So if I put this becomes 4 square plus 4 raised to the power 4. This comes out to be nothing but 272. So a very beautiful question, because otherwise if you take x equal to 2, you might get the wrong answer also. Now let us move to our next problem type, that is questions based on polynomial equations. So now let us first see some basic theory on which this kind of questions are based, and then move on to questions. So when we are dealing with polynomial equations, there are 2-3 things that we need to know. The first is number of roots. So let us say if I have an equation that looks like that, a0 plus a1x plus a2x square and an x raised to the power n equal to 0. You can see that since here an is not equal to 0 and a0, a1, a2, a3, an are all real, this is a polynomial equation. If this is the polynomial equation, the first thing that you need to know is number of roots will be equal to degree. So you can see that the degree here is n, so the total number of roots are going to be n. So if it is a 6th degree equation, total number of roots are 6. 7th degree equation, total number of roots are 7, so on and so forth. Now, whenever the coefficients are real, one more result will come into picture. So this was my first result. Another result will come into picture, that your imaginary roots will occur in pair, will occur in conjugate pairs. Now this is essential because if you simplify it, and if this condition is not true, what you are going to end up with is non-real coefficients. And since it is given they are real, this is bound to happen. So what I'm saying is, let us say if there are 5 roots, so one can be 1, 2, 3, this is possible. But other two, if they're imaginary, they need to be of this form only. So you can see that these two are conjugate. So this is a very important property, will be very useful in finding number of roots. Another result that is very useful, or the second result, is the nature of these roots. Now let us understand a very fundamental thing. So most of the times, the number of roots, nature of roots, this one thing, for this you will have to use derivatives in higher degree. So whenever you are dealing with cubic or more than that, you will have to use this derivatives concept to come up with the nature of roots. So what you can do is, let us say that a polynomial equation is given to you. So what we can do is, we can find the value of f dash of x equal to 0. Now let us say that your fx was cubic, and if you put this equal to 0, you will get two roots, x1, x2. Now using this, what you can do is, you can study the nature. How? So if you find the f of x1 and the value of f of x2, and now 2-3 things can happen. One, both of them are positive, both of them are negative, one of them is positive, another is negative. These two things can happen. So in the first scenario, assuming that your a is greater than 0, it is going to look something like this. So something like this. So now what they are saying is, these both roots are something like this. So this is your point x1 comma f of x1, and this point is nothing but x2 comma f of x2. So in the first case, what they are saying is, both of them are positive. This would mean, in our first scenario, it is going to look like this. So you can see that only one real root will be there, and the next two will be imaginary. So our first case is corresponding to this diagram. If I look into my second case, let us also try and understand what is going to happen in that case. So both are negative. So in that scenario, both the roots will lie below the line. So still you can see there is one real root only. And in the third case, when we can see that the first one is positive and the second one is negative, this will happen in a scenario where you can see that this goes like this, then it becomes negative, then like this. So you can see that there are going to be 3 real roots, 2 and 3. In the fourth scenario, the first one is negative, then the next one is positive. So you can see that in this a greater than 0, this is not possible. So this is going to happen when I turn the graph around. So this is only possible when a is smaller than 0. So for a greater than 0, we can see that there are 3 possible scenarios. Very important to understand. Now one more thing can happen. If one of the roots is, if I find this value f of x1 into f of x2, this is equal to 0. So what would this mean? So let us say at x1 it is becoming 0. So if I start from below, it will touch like this and it will move on. You can see that there are 2 overlapping roots coming at this point. So what I did earlier was, I took this f dash of x equal to 0. The roots x1, x2 were corresponding to this. So if this is happening, so there is a point at which the function is also 0. And at the same time, f dash of x1 is also 0. So this will corresponding to repeated roots. Okay, the more times f dash of x will become 0, and that many time repeated roots will be there. The fourth important idea while actually finding the roots would be that if an equation is written like that, a n x raised to the power n, a n minus 1 x raised to the power n minus up till a naught x raised to the power 0, a common tendency to solve this would be to find factors of a naught and substitute in place of x and check which of them is getting satisfied. So this hit and trial technique is used in a lot of questions. Now if I move to the fifth point, that is nothing but a relation between roots and coefficient. Now this is a very interesting idea. Why? Because let us say that we have an n degree equation polynomial equation that looks like this. So what we can write is this equation is going to have n roots, alpha 1, alpha 2, alpha 3, alpha n. So if I want to write sum of the roots, it will be equal to this minus a n minus 1 by a n. If I take two of them in pair, alpha 1, alpha 2, all such pairs, and add them up, it is going to be plus a n minus 2 by a n. And if I keep on doing so, you can see that there will be alternate negative positive sign. So if I reach towards the last part, when I'm multiplying all of these roots till alpha n, it is going to be minus 1 raised to the power n, a naught by a n. So it is interesting that if the value of n is nothing but odd, like x cube, in that scenario you will get a minus a naught by a n part. But let us say that this n is even. In that scenario, we are going to end up with plus a naught by n like we do in quadratic. Now, this is a very generalized result, will be used in solving a lot of questions. Now, let us see what kind of questions JEE has based on this idea. Now, let us look into this question that was asked in 2023. See, most of the cases you realize that these kind of questions are based on common sense and logic. This question uses the idea of relation between roots and coefficients. So, if I have product of three roots alpha, beta, gamma, I can write this as minus c by a, that is 1. Alpha is given as minus 1 and beta gamma is given as 1. So you can see that the value of c comes out to be 1. This is the first part. The second part, what we can do is, in order to find the value of b, let us find first the value of beta and gamma. So another relation that we have is, if I write sum of the roots, it will be equal to minus of coefficient of x square, that is nothing but 0, by a, that is nothing but 1. Now here alpha I already know, that is minus 1. So alpha, beta plus gamma will be equal to 1. Since alpha is minus 1, we can substitute the value. We know the value of alpha, beta, beta gamma also. That is given nothing but again equal to 1. So let us try and simplify this. So if try and simplify this, what am I going to get is beta plus 1 by beta is equal to 1. Or beta square minus 1 plus 1 minus beta. Now, if you further simplify this, you get an equation that looks like beta square plus beta plus 1 is equal to 0. Minus beta plus 1 is equal to 0. So if I write this one and find the value of beta, a very interesting result comes through. And this we have also done. So there was a result that I told you earlier, that if you have x square plus x plus 1 equal to 0, the roots are omega and omega square. At the same time, if you have x square minus x plus 1 equal to 0, it is going to have roots minus omega and minus omega square. This is very important because now you have figured out all the three roots. Your cubic equation has one root as minus 1, another as minus omega, and another as minus omega square. And if you closely observe this, you will realize that these are nothing but cube roots of minus 1. So our equation should look something like this. If it looks something like this, then if I write it in the third step, my equation becomes x cube plus 1 equal to 0. Now after looking into this, you have got the value of c, you have got the value of b as 0, you have got the value of alpha as minus 1, beta as minus omega, and gamma as minus omega square. All we need to do is put all of these values in this expression and simplify. And if you do so, you will see your B option will match up. Now, as I told you earlier, if a question based on number of roots is asked to us, or the nature of roots is asked to us, what we need to do is use derivatives. So I will take this function fx is equal to x raised to the power 7 minus 7x minus 2 and differentiate it. So if I differentiate it, what I get is 7 into x raised to the power x raised to the power 6 minus 7. And if I simplify this, what am I getting from here? 7 into x cube minus 1 into x cube plus 1. And again, if I simplify, it is nothing but x minus 1 into x square plus x plus 1. And the next part is x plus 1 into x square minus x plus 1. Now we know that this equation will have two real roots. That is nothing but, if I put it 0, x equal to 1 and x equal to minus 1. For the other two quadratics, they have nothing but imaginary roots. So you are getting only two real answers. This is my first step. In my second step, what I need to do is find the value of function at 1. If I put it 1 in this function, what you are getting is 1 minus 7 minus 2. This is actually a negative quantity, and that is equal to minus 8. If I find the value of minus 1, what am I getting is nothing but minus 1 plus 7 minus 2, and that is nothing but 4. So in the third part, if you try and understand what is really happening, so based on the value of n, it needs to have, it is 7. So ideally we can have 7 roots. But you can see that once we start plotting the curve, it will be something like this. And this point that is at minus 1 is coming out to be positive as 4. And this point that is at 1 is coming out to be minus 8. So what is happening is your x-axis passes between them. And what is happening is this curve is going to cut the x-axis at 3 points. So there are going to be 3 roots. Hence the option D is the correct answer. Now in this next question, again, if you observe this equation that is given to you, we are going to assume this as a function x raised to the power 7 plus 5x cube plus 3x plus 1. Then we are going to differentiate it, because that is the standard operating process that we have for any kind of equation that is there. So this becomes 15x square plus 3. Now if you look into this expression, if I put x smaller than 0, it is going to be positive. If I put x greater than 0, it is going to be positive. If I put x equal to 0, still it is going to be positive. So you can see that this is always greater than 0. And since the degree is odd, this is very important. So the next step, so if you start plotting this curve, it will start from here. It will take some path and go like this. So while going from minus infinity to plus infinity, it is going to cut the x-axis as one point. And from here, you can tell that the answer of this question is going to be B, one real solution. Now here you need to know two small results which are very connected to this question. So whenever we are writing the degree of an equation as an odd number, in that case it is bound to have one real root. The reason is that it will start from minus infinity and go like this to positive infinity. So at least one time it will have to cut the x-axis. So at least one real root would be there. But if n is even, in that case, it might happen that the curve will dance through and go above. And it is possible that there might be zero real root as well. So zero real root is also possible. But this first idea is used in a lot of questions. Now this next idea is based on finding the actual roots of the equation. The equation is given to us and we know that there are going to be 7 roots. Now one I can directly find just by taking x common. So it becomes x raised to the power 6 plus 3x raised to the power 4 minus 13x square minus 15 equal to 0. So one root you can observe is nothing but x equal to 0. This we have already got. Now if I take this equation, that is nothing but x raised to the power 6. Here I can put x square as nothing but t. And if I do so, it becomes a cubic. T cube plus 3t square minus 13t minus 15 is equal to 0. And now what is the method? Method, as I already told you, we need to take this minus 15 and write its factor. So one of those factors is going to be 3. So let us check whether this is getting satisfied for 3 or not. So if I do so, what you will observe is this becomes a 27 plus 3 into 3 square minus 13 into 3 minus 15. And if you simplify, it is 27 into 2. This becomes 39 minus 15. So this is nothing but 54 minus 54. It comes out to be 0. So you can see that from hit and trial, we get one of the roots as t equal to 3. If I move forward, what I can do is basically divide this equation by t minus 3. So if I do so, I will get my other roots. So let us write here t minus 3. T cube plus 3t square minus 13t minus 15 will get. So here if I write t square, this becomes a t cube minus 3t square minus plus. And then this becomes 6t square minus 13t minus 15. So if I write plus 6 here, so this becomes 6t square minus 18t minus plus. So what you get is nothing but 5t minus 15. And again, if I put here plus 5, this will become 5t minus 15. That comes out to be 0. So if I divide this by t minus c, the remaining part is this one. And this you can see prima facie, you will get other two roots, that is t plus 1. You can factorize it into t plus 1 into t plus 5. So if I take my original statement, now in the third step, so this was my second step, this was my fourth step. In my third step, I can understand that there is one factor as t plus 1. There is another factor as t plus 5. And what we got was t minus 3 equal to 0. So the possible values of t that we can have, see t was nothing but x square. So let us now write it x square. So if I write it x square, it can be equal to minus 1. X square can be equal to minus 5. And x square can be equal to 3. So plus minus I. The second part, it comes out to be x equal to plus minus root 5i. And the third one comes out to be nothing but plus minus root 3. Now next, if I try and observe what will be your alpha 1, so based on the condition that is given in the question here, you can observe that your alpha 1 is going to be nothing but root 5i. Alpha 2 is going to be minus root 5i. Alpha 3 is going to be nothing but root 3. Alpha 4 is going to be minus root 3. Alpha 5 is going to be I, and alpha 6 is going to be minus I, and alpha 7 is going to be 0. So once you observe this and put the value, so if I multiply the first two, I will get 5. So the value of my expression becomes 5, then plus 3 plus 1. So if you add them up, the answer comes out to be 9. So what I have done is nothing but substituted the value in this expression and got my answer. A very interesting question. Now let us look into this next question. It is based on the idea of factorization. So if I take this first part and if I factorize this, I can take x square common. So it will be x minus. If I take minus sign common, it is x minus 1 again. From the second part also, I can write this as 3x cube minus 3x square minus x square plus x minus 3x plus 3 plus 1 minus 1. Again, if I simplify this, this becomes x raised to the power 5. Can be written as x square minus 1 into x minus 1. Here again, I can take this 2 and this 1 I can separate. So if I do so, what am I getting? From the first part, it becomes 3x square into x minus 1. From the second part, x into x minus 1. From the third part, 3 times x minus 1. And the last part I can take out and write again as x minus 1. What we can observe from here, what I get is nothing but x minus 1 is common, and then x raised to the power 5 into x square minus 1. From the middle part, I will again get 3x square minus x minus 3 plus 1 equal to 0. And now what I can do is, if I rearrange the terms a little bit, what I'm getting from this is nothing but 3x cube minus 3x and minus x square plus 1 equal to 0. So now x square minus 1 can be taken out from this x square minus 1 can be taken as common. And if I do so, it becomes x minus 1 into x square minus 1, x raised to the power 5 plus 3x minus 1 equal to 0. If I look into this two parts, we are clearly looking into 3 real roots. But if I look into this part, and if I write it separately as a function, and if I differentiate this, what am I getting is nothing but 5x raised to the power 4 plus 3, which is always greater than equal to 0. So this is again going to give me one more real root. Now let us go back to the question. Says number of distinct real roots. We can see that out of this, the 3 real roots are nothing but there are 2 ones and 1 minus 1. Out of here, I will get one more distinct. So here from here, I am getting 2 distinct real roots. Out of this, I will get one more distinct real root. So if I add that up, that comes out to be 3 distinct real roots. So my answer to this question comes out to be 3. So direct question based on factorization. Now this 2022 question was a very tricky question because what they want us to do is take reciprocal of the equations that are given to us. And if I do so, this is what I will get. And once I've taken those reciprocals, the thing to be observed here is the difference of the numerator and denominator is same. So what I can do is I can subtract minus 1 from both sides. What I need to do is simplify. So this becomes nothing but minus 2x square plus 12x minus 9. And this becomes 3x square minus 9x plus 17 is equal to minus 2x square plus 12x minus 9 by 5x square minus 7x plus 19. So you can see that you are getting identical numerators in both the places. This is critical because if I take this minus 2x square plus 12x minus 9 equal to 0, I will get some solutions from here. Interesting thing is, if you check D for this, it is coming out to be greater than 0. So both the roots are real. And if I write sum of these roots, it is going to be minus 12 by minus 2. It is going to be 6. Now let us look at the remaining part. So if I cross multiply now, this is the remaining part. And if I simplify, it becomes 2x square plus 2x plus 2 equal to 0. Which is nothing but x square plus x plus 1 equal to 0. And we clearly know it has d is smaller than 0, hence no real root. So you can see that the sum of the real roots possible comes out to be 6. So answer to this question is nothing but 6.
Now this 2024 question talks about a quadratic equation whose roots are already given as x1, x2, x3, x4. They want us to find the product of this expression. So we can approach this question in this manner that I want a biquadratic equation in such a manner that it has roots x1 square plus 4 and so on and so forth. The pattern is that, and what we want to ultimately find as an answer is nothing but product of the roots of this equation. Now, this is a clear-cut identification of problem types as nothing but transformation of equation. So what you will have to do is you will have to transform the equation to get an answer. The process is very simple. In the first step, let us write 4 plus x1 square is as nothing but y1. Y. Once we have done that, you can see that the value of x1 here becomes y minus 4 ka root. Now take this value, and since this is one of the roots of the original equation, it will satisfy. So 4 times root y minus 4 whole square plus 8 root of y minus 4 whole cube minus 17, this will become y minus 4, and then minus 12 root y minus 4, and ultimately what we have is nothing but 9 equal to 0. So you can see that we have got an equation. It is not exactly the equation that we wanted, but we have got an equation. If I simplify, this will become 4 times y square minus 8y plus 16. Then we will take this term. So this term and this term we will take on one side. What we have is nothing but minus 17 times y plus 4 into 17. And the next step is to write 9 here. And rest of the things we'll take on the other side. To 12 times root of y minus 4. And this will become minus 8 times root of y minus 4 into y minus 4. So this is the expression that we have got. It is not a biquadratic, so 4 roots are not possible, but we can do a simple step and that will make our life very simple. So in all such questions, we are going to first simplify and then square one more time to remove this root sign. So if I simplify, y 4y square will come. 4 into 8 is 32. From 32, in 32 if I add 17, so 32 plus 17 is going to become 49. So this will become minus 49 times y. 64 plus 4 into 17 plus 9 would be there. And on the other side, if you write, what we have is nothing but 12 minus 8y plus 32 into root of y minus 4. Now there are two more steps to be taken. Fourth step would be to square both the sides. And fifth would be check the product of roots of this new equation. You will get your answer.
This type 11 question is, are those equations which are reducible to quadratic equation? Now there are many such category of questions. I am going to illustrate all of those types taking previous year questions only. So let us start with it. So if I look into this first question that came into 2023, this is a very typical question that works on this idea that if I take root 3 plus root 2 and if I find its reciprocal, something very interesting happens. If I rationalize this, what I get in the numerator is root 3 minus root 2, and in the denominator it becomes 3 minus 2, that is 1. So the interesting part here is that root 3 plus root 2 and root 3 minus root 2 are actually reciprocal to each other. So if I consider this as t, this is going to become 1 by t. And this is very interesting. We are going to use this to solve this question. And there are many such questions which are based on this small trick. Now, if I take this, you can see that the first part can be written as t raised to the power x square minus 4, wherein the second part can be written as 1 by t raised to the power x square minus 4 is equal to 10. If you're a little bit more smart, instead of assuming this as t, we could have taken raised to the power x square minus 4 as t. So this part would have become again as 1 by t. And now this would be even shorter. So instead of doing this, let us do this. So this x square minus 4 will go away. And we are left with a very simple quadratic equation. And if I simplify this, this becomes 10 square minus 10t plus 1 is equal to 0. And if I solve this using quadratic formula, it is 10 plus minus root of b square, that is 100, minus 4ac by 2a. So if I simplify, what I get as value of t is nothing but 5 plus minus, this becomes root of 96. So if I simply write this simplification, what I can do is I can take this 4 out of this and this becomes root 6. So what is happening now? Now this is nothing but root 3 whole square plus root 2 whole square plus minus 2 root 2 root 3. And this is a very important statement because this can be written as root 3 plus minus root 2 whole square. So essentially, if I take the value of t, that was nothing but root 3 plus root 2 raised to the power x square minus 4. So we can see that there are two possible values of x square minus 4. One of those values is nothing but plus 2. And another value is nothing but minus 2. Because the reciprocal will again be equated to that. So if I do this from the first case, what am I getting is nothing but x square is equal to 6. And from the next case, what am I getting is nothing but x square equal to 2. So you can see that there are 4 set of values that are possible: plus root 6, minus root 6, plus root 2, minus root 2. Hence, B option 4 becomes our correct answer. Now, this next type of question that came into 2023 is based on the idea that I can take x plus 1 by x as t. If I do so, and if I square it, it becomes this is equal to t square. Now we can use these two ideas to solve this question. So now I can reduce my question into the first part can be written as t square minus 2 times t plus 5 equal to 0. Now this is a quadratic. So 3t square minus 6 minus 2t plus 5 is equal to 0. So this becomes 3t square minus 2t minus 1 is equal to 0. And if I simplify this, t comes out to be 2 plus minus root of b square minus 4ac by 2a. Now I can cancel this 2, and this can be written as 1 plus minus 2 by 3. If I take plus sign, it becomes that value of t comes out to be 1. And if I take minus sign, the value of t comes out to be nothing but minus 1 by 3. And once you have got both of these values, this my first step is done. Let us move towards second step and find the value of x plus 1 by x. So one value that we got was 1. So in this scenario, x square plus x minus x we are going to get. So x square, sorry, plus x. So x square minus x plus 1 will be equal to 0, and we know that here d is smaller than 0. So no real root. But if I take the other one, that is x plus 1 by x is equal to minus 1 by 3. Now in this scenario, let us see what happens. So this becomes 3x square plus 3 is equal to minus x, and 3x square plus x plus 3 is equal to 0. Now let us look into the question that is given to us. Question talks about number of real. So if I find the value of d here, it is nothing but b square minus 4ac. Again, you can see it is smaller than 0. So you can see that both the roots that we got had imaginary roots. Hence, there are 0 real solutions. That is option C. Now, this question asked in 2022 covers a specific type of polynomial equation that is known as, or equation reducible, that is known as but nothing but reciprocal equation. The trick lies in dividing by x square, and if you do so, it becomes x square minus 3x minus 2 plus 3 by x plus 1 by x square. So if I do so, you can group these terms, and if I do so, it becomes or reduces into our last question that we just solved. And what am I getting here is x minus 1 by x minus 2 is equal to 0. So now what you can do here is we can assume this part as t. So if I put x minus 1 by x as t, so this was my first part. Now this is my second part of the question. So this becomes x square plus 1 by x square minus 2 will be equal to t square. Now in the third part, let us substitute these values and see what kind of answer we are getting. So this becomes nothing but t square plus 2. This is my first part. The second part is nothing but minus t minus 2 is equal to 0. So it becomes a t square minus 3t equal to 0. So the value of t comes out to be 0, and t can also be equal to 3. Now we need to put the values of t here. So if I put t as x minus 1 by x equal to 0, x square minus 1 will be equal to 0. So the value of x comes out to be plus minus 1. And if I do this for the other part, then x minus 1 by x equal to 3, or x square minus 3x minus 1 will be equal to 0. Now once we have done this, something interesting we need to know. What we want is, let us say that this next equation has roots as alpha and beta. So what we want in the fifth part is nothing but the sum of cubes. So the sum of 1 cube plus minus 1 cube plus alpha cube plus beta cube we need to find. Now interestingly, the sum of the first two terms will be equal to 0. So what I ultimately need to find is alpha cube plus beta cube. This I can write as alpha plus beta into alpha square plus beta square minus alpha beta. This in turn can be written as alpha plus beta into alpha plus whole square minus 3 alpha beta. Let us put the value. So if I put the sum of the roots, it is nothing but 3. This becomes 9 and this becomes 3. So if I simplify it, it comes out to be 36. So you can see that there is one part that is known as reciprocal equation. And that again solves, and again towards the end we have to use relation between roots and coefficients. Now this is a very simple question that came into 2022, and it is on your face. You can just substitute e raised to the power x as t, and if I do so, it is t square minus 4. This becomes nothing but 6t square minus 5t plus 1 equal to 0. If I take the first part, the value of t comes out to be plus minus 2. If I take the second part, t comes out to be nothing but 5 plus minus root of b square minus 4ac by 2a. So this comes out to be 5 plus minus 1 by 12. So if I take plus sign, the value comes out to be 6 by 12, that is nothing but 1 by 2. And if I take minus sign, it comes out to be 4 by 12, that is nothing but 1 by 3. Now let us take all of these values at the same place. In the second part, this was my first part. What I can do is I can put e raised to the power x as values of t. So the first value that we got was plus 2. So corresponding to this, x comes out to be ln 2 or log of 2. In the second part, if we put it equal to 2, this is not possible. Third part, if I take e raised to the power x as nothing but 1 by 2, x will come out to be minus ln 2. And in the third part, e raised to the power x is equal to 1 by 3. So x comes out to be minus ln 3. Now if I add this value, this, the first two will get cancelled out and third will get as answer, which is nothing but option B. Now the question of this question and the question before that, that is a reciprocal equation. So again, we can do it in baby steps. So what you can do in the first part is to put e raised to the power x as t. If I do so, this is t raised to the power 4 plus 8t cube plus 13t square minus 8t plus 1 equal to 0. Again, now this becomes a reciprocal equation because the coefficients of term equidistant from the center, you can see there is a relation between them. So if I divide this by t square, what I get is t square plus 8t plus 13 minus 8 by t plus 1 by t square equal to 0. If I take terms, first term and the last term, it is nothing but t square plus 1 by t square. Now this exact question we did some time back. And then these two terms I can combine and it becomes 8 times t minus 1 by t. And then what we have got is 13 equal to 0. In this third part, what you can do is you can put t minus 1 by t as nothing but v. Second substitution. So if I square is t square plus 1 by t square minus 2 will be equal to v square. And if I put this is first term will be v square plus 2. The second term will be 8v. So once we simplify this, what we get is v square plus 8v plus 15 equal to 0. And if you see, this can be factorized as v plus 3 into v plus 5. Now let us go to the fourth part and decode what it means in terms of t and then in turn in terms of x. So t from the first part, v becomes minus 3. So t minus 1 by t would be equal to minus 3. This translates into t square plus 3t minus 1 is equal to 0. So the value of t from here comes out to be minus 3 plus minus root of b square minus 4ac by 2a. So if I do so and equate it to e raised to the power x, we can only take the plus sign here. This will become root 13 by 2. So you can see that corresponding to this, the value of x that we will get. So root 13 is somewhere between root of 9 and 16. So this is nothing but 3.5 something minus 3 by 2. So approximately if you look into this value, this is 1 by 4. E raised to the power x would be negative. If you look into the graph of e raised to the power x, it will become 1 at x equal to 0. So if I'm getting value smaller than 1, that means in this case x will be negative. We can do the same calculation for the next part. V will be equal to minus 5. So t minus 1 by t is equal to minus 5. So t square plus 5t minus 1 is equal to 0. And from here, the value of t comes out to be minus 5 plus minus root of b square minus 4ac by 2a. And again, you can see that the value of t, that way the negative part is not acceptable because this is e raised to the power x. So minus 5 plus root of 29 by 2. So this is nothing but 5 point something. So again, from here also x that we are getting is nothing but negative. So what we can observe, let us go back to the solution. So there are two solutions. Yes. This also talks about 2. Now 4 is not there, no solution. And both of them are negative. So A option becomes correct. Now this next question is based on the idea of factorization. So if I factorize the first part, it is x minus 1 into x minus 3. Next one can be written as x minus 3 into x plus 3. And the last one can be written as times 2x square minus 7x plus 3. Next, if I write the remaining part after cancelling it out, it becomes x root of x minus 1 plus root of x plus 3 is equal to root of 4x minus 2. Now if I square it, this is what am I getting. And this is interesting because it can be further simplified into x square plus 2x minus 3 is equal to 4x minus 2. So this left hand side becomes 2x plus 2 plus 2 root of x square plus 2x minus 3 is equal to 4x minus 2. After simplification, it becomes 2 times root of x square plus 2x minus 3 will be equal to 2x minus 4. So this 2 can get cancelled out. And again, I can square to simplify it. And if I do so, this becomes x square minus 4x plus 4. X square will again get cancelled out. So 6x will be equal to 7 and x will be equal to 7 by 6. But if you try, it does not satisfy the initial equation that was given to us. So there is only one real root, that is x equal to 3, hence B becomes the correct.
If I look into this 2024 question, it talks about sum of all the solutions of this equation. So in order to solve this equation, it is equation reducible to quadratic. We will put 8 raised to the power x as t. Once we have done that, you can clearly see the quadratic t square minus 16t plus 48 is equal to 0. Now, if we are writing this, it will make sense. If I look into the factors, so 24 into 2 we can write, or 12 into 4. So you can see that this can be written as t minus 12 into t minus 4 is equal to 0. So we are getting two values of t, 12 and 4. So 8 raised to the power x will be equal to 12. 8 raised to the power x will be equal to 4. From this first part, we are getting the answer of x is nothing but log of 12 to the base 8. From the second part, we will get x is nothing but log of 4 to the base 8. In the third part, they are asking the sum. If I add them up, log of 12 to the base 8 plus log of 4 to the base 8, this will become log of 12 into 4 to the base 8. So this is log of 48 to the base 8. If I want to, now if you simplify this, you will see that this can be written as nothing but 48. So if I talk in terms of, so what I can do is, if I divide by 8, so this can be written as 8 into 6 to the base 8. I can split it up and write log of 8 to the base 8 plus log of 6 to the base 8. The first part becomes 1 and the second becomes log of 6 to the base 8. It is a combination of equation reducible to quadratic and log. Our option A matches. Now this 2024 question is a very famous question. What we will do in this question is, in the first part, you will take a root of x, root of 3 plus root 2. And what to observe here is the reciprocal of this part is nothing but root of 3 minus root 2. So if I put root 3 plus root 2 raised to the power x as t, the other part, that is root 3 minus root 2 raised to the power x, will become 1 by t. So in the third step, when you do it, this is t plus 1 by t is equal to 10. Once you have got this expression, you can see that you have got a quadratic expression, t square minus 10t plus 1 is equal to 0. So value of t comes out to be 10 plus minus root of b square minus 4ac by 2a. So we have, you can see that clearly got what they're saying is number of elements in the set S. So number of elements are going to be 2 only, because corresponding to each of these answers you will get one value of x. So answer from here only you can put as 2. If I look at this 2024 question, it is an observation based question. So if you write this down as x square is equal to 2 raised to the power y plus 2023. See, this part can add and make a perfect square only if y is equal to 1. So when y becomes equal to 1, your right hand side will become 225. So that is nothing but the square root of 225 is nothing but x. So x will come out to be 45. There are only these two possible where it works out. So the answer of this question becomes x plus y. That will be 1 plus 45. Answer will become 46.
Now this last type of problem, that is type 12, is based on modulus equations and inequation. So here you need to know some very fundamental ideas. The first one is, if you have modulus of a function, it can be interpreted as fx when the function in the modulus is greater than or equal to 0, and minus of fx when the function inside it is smaller than 0. And based on this, we have two very important results. Sometimes an equation can be based on this idea like this. So this is only true when fx is greater than or equal to 0. And one more equation can be formed, modulus of fx is equal to minus of fx. Now this is also only true if fx is smaller than or equal to 0. So if this is given, we'll write this second part to get the answer. Another very important result that you can use is nothing but if you have something like fx plus gx modulus is equal to fx ka mod plus gx mod. So this is only true when fx and gx have same sign. That would mean their multiplication needs to be greater than or equal to 0. Now let us see what kind of questions JEE has based on this. Now let us start this question that was asked in 2023. So this question involves removal of this modulus signs. What you can do is, in order to remove multiple mod signs, draw a number line, put the quantity inside first mod equal to 0. What we'll get is x equal to 0. If I put the quantity inside the another mod equal to 0, I will get minus 2. So I need to make three cases. One, values of x is smaller than minus 2. Second, between minus 1 and minus 2 and 0. And third, greater than 0. So if I take my first case, let us see what kind of answers am I getting. So I am putting value of x is smaller than minus 2. So if I take this value, my first modulus sign will open with a negative sign. So minus of x square. Second will also open with a negative sign. So plus x plus 10 plus 6 equal to 0. If I write this up, it is minus x square plus 5x plus 16 equal to 0. If I solve this equation, the values of x that I am getting is nothing but 5 plus minus root of b square minus 4ac by 2a. You can see that one value of x comes out to be 5 plus root of 89 by 2, and another comes out to be 5 minus root 89 by 2. So you can see that this value is clearly greater than minus 2 and this value is smaller than minus 2. So this is our acceptable answer. So we are getting one answer from here. Let us move on to the next part. The next part, we are taking values of x that lie between nothing but minus 2 and 0. Now what will happen is, the first sign will open with a mod will open with a negative sign. The second will open with a positive sign. And what we will get is nothing but minus 5x minus 10 plus 6 is equal to 0. And this comes out to be nothing but minus x square minus 5x minus 4 is equal to 0. So x square plus 5x plus 4 equal to 0. And I can factorize this as x plus 1 into x plus 4. So the value of x comes out to be minus 1 and minus 4. You can again see that minus 4 is not acceptable, but minus 1 is acceptable. So we've already got two real roots. Now let us move towards the case 3. So if I take my case 3, let us see what happens in this case. So in my case 3, I can again consider the value of x is greater than or equal to 0. And if I do so, this becomes minus, in this case, plus x square minus 5x minus 10 plus 6 is equal to 0. So x square then minus 5x, then minus 4 is equal to 0. And if I simplify this, 5 plus minus root of b square minus 4ac by 2a. So we can see that there are two answers we are getting from here. The first is 5 plus root of 35 plus 6, 41 by 2. Another one is 5 minus root 41 by 2. We can see that this another answer is negative, but the first answer is fine. So we can see that in this question we are getting 3 real roots, each one in one case. So answer B becomes correct. Now if I look into this next question, again asked in 2023, we can do the same type of interpretation we did in the last question. Put this equal to 0, we get 1. Put this equal to 0, we get minus 2. Case 1, case 2 and case 3. Now let us consider these cases separately. If I take my case 1, my x is smaller than minus 2. And both the mods will open with a negative sign. So minus x square plus x minus x minus 2 plus a will be equal to 0. So what am I getting from here is nothing but minus x square minus 2 plus a is equal to 0. So the condition is x square will be equal to nothing but a minus 2. If I look into the second part, let us see what we get from there. So if I take the values of x between minus 2 and 1, let us see what we are getting from this case 2. So in this case, what will happen is the first will open with a negative sign. So minus x square plus x. The second will open with a positive sign. X plus 2 plus a is equal to 0. If I simplify this, this is minus x square plus 2x plus a plus 2 will be equal to 0. So if I simplify this further, what I get is the value of x comes out to be minus 2 plus minus root of b square minus 4ac by 2a. So if I write these values, what am I getting here is nothing but 1 plus minus root of a plus 3 after simplification. If let us consider the case 3. If I consider case 3, x will be greater than 1. If I take value of x greater than 1, all the modulus will open with a positive sign. So you can see that your x is getting cancelled out in the first step. So x square will be equal to minus a minus 2. Now after this step, let us check options. So in options, what they're saying is the first part talks about all the real numbers. The second talks about value of a being greater than minus 6. Third talks about smaller than minus 3. So if I check my answer for two specific values, I will be able to separate all the answer. The one is a equal to minus 6. If I check for a is equal to minus 6, I can see that from case 1 I will get nothing. From case 2, if I put again, I will get nothing. But from the last case, I will get one answer. You can see that a is equal to 6 is a valid option, so it needs to be there. So now you can see that x is equal to minus 6 is only involved in a and c. In order to separate them out, also check it for a is equal to minus 3. If I put minus 3, you can see from the first one I will get nothing. From the second one I get 1. And from the third one I get nothing, because here in this condition x needs to be greater than 1. Hence again one option correct. So your option A comes out to be correct. So what you need to do is you need to make those cases and check the options to get to the right answer. So this question was asked in 2021. Again similar kind of question. What we need to do is interpret the modulus. So if I take two cases, in one let us take x is smaller than 5. So in this first case, first square, perfect square can be opened as x square plus 2x plus 1. Modulus will open with a negative sign, so minus x plus 5 is equal to 27 by 4. If I do this, what will happen is this will become x square plus x plus 6 minus 27 by 4 is equal to 0. So this becomes x square plus x, 4 into 6 is 24. So this becomes minus 3 by 4 equal to 0. So if I try and find the value of x, it is minus 1 plus minus root of b square minus 4ac, that will become nothing but 3. by 2a, that is nothing but this. So minus 1 plus minus 2 by 2. So you can see if I take plus sign, the answer comes out to be 1 by 2. And if I take minus sign, the answer comes out to be nothing but minus 3 by 2. Since the value of x is smaller than 5, both of these are acceptable answers. Now let us move on to the another case. This case talks about the value of x greater than equal to 5. In this case, again we will write x square plus 2x plus 1, but the modulus will open with a positive sign. So this is what we are getting. If I simplify, this becomes x square plus 3x minus 4 minus 27 by 4 will be equal to 0. Or x square plus 7x 16 plus 27 by 4 will be equal to 0. So x square plus 7x. Now if I simplify 16 plus 27, it is going to be 37 plus 6, that is nothing but minus 43 by 4 equal to 0. Now let us apply a quadratic formula and see what we are getting. Minus 7 plus minus root of b square 49 plus 43 by 2a. So if I simplify this, if I take plus sign, let us see what I get. So if I take plus sign, because in minus, obviously, it will not get satisfied. And only minus plus sign is something that we need to consider. So minus 7 plus root of, this will become nothing but 50. If I add 1, 50, then 50 plus 42 is nothing but 92 by 2. So 92 is something. So this is 9 point something. So 9 point. So minus 7 plus 9 point something by 2. So this will become nothing but approximately equal to 1. So again, this is also not falling in the range of greater than 5. So this is also not an acceptable answer. Hence, there are only two values possible. So answer of this question comes out to be 2. Similar as our first question that we solved. Now in this next question, what we have is a modulus sine over x square minus 5x minus 8x plus 15. So we can take two cases. Let us open first this modulus sign with a plus sign. If I do so, this is what am I getting. In this case 1, if I do so, my value, and if I simplify, this comes out to be x square minus 10x plus 22 equal to 0. And now, if I simplify, the value of x comes out to be 10 plus minus root of b square minus 4ac by 2a. So if I divide by 2, this becomes 5 plus minus root of 25 minus 22. So 5 plus minus root 3. This is the answer of the first part. Second part talks about the value when x square minus 8x plus 15 will open with a negative sign. If I open this with a negative sign, this is what I get. So this is equivalent to x square minus 8x plus 15. And let us multiply. What I have done is multiplied by a minus sign. So this is what am I getting. If I simplify this, this comes out to be x square minus 6x plus 8 is equal to 0. And this can be written as nothing but x is equal to 6 plus minus root of b square minus 4ac by 2a. And that if I simplify is nothing but 6, 3 plus minus root of 9 minus 8. So that is nothing but 3 plus minus 1. So your answer comes out to be 4 and 2. Now let us talk about acceptability of these answers. So when we solved our first case, what we ideally took was x square minus 8x plus 15 to be greater than equal to 0. And if I simplify this, this is nothing but x minus 3 into x minus 5 greater than equal to 0. So we are talking about values which are either smaller than equal to 3 or values of x that are greater than equal to 5. So when I'm getting my answer is 5 plus root 3, this is an acceptable answer. Why? Because this is greater than 5. But if I look into the other answer, that is 5 minus root 3. This is an unacceptable answer because it is not smaller than 3 and lies between 3 and 5. Now, if I look into my second part of the problem, it talks about two answers 4 and 2. Again, in this second part, x square minus 8x plus 15 needed to be smaller than 0. And this will happen when x lies between 3 and 5. So out of these two values, only 4 lies between 3 and 5. So this is acceptable answer, but the 2 is not an acceptable answer. So what they're saying is sum of all the roots. So the roots are nothing but 4. And another root came out to be 5 plus root 3. So if I add them, the answer that I'm getting is nothing but 9 plus root 3, which is given in option B, and hence it becomes the correct answer. Now again, let us do the same thing. Interpret the moduluses. So again, we are going to draw the number line. The first modulus, if I put it equal to 0, it is nothing but 0. Second one mod, if I put equal to 0, it is nothing but minus 4. So case 1, case 2, and case 3. Let us try and solve all of these cases and get the answer. So if I take my case 1, I'm going to consider value of x smaller than minus 4. And if I do so, my first mod will open with a negative sign. Second mod will also open with a negative sign. So if I simplify, it is nothing but x plus 3 into x plus 4 is equal to 6. So x square plus 7x plus 12 will be equal to 6, or x square plus 7x plus 6 will be equal to 0. And if I factorize, it is x plus 1 into x plus 6. So the values of x that we are getting are nothing but minus 1 and minus 6. Since only minus 6 is smaller than 0, this is our acceptable answer. Minus 1 we cannot accept because it is greater than minus 4. Now if I start with the second part of the same question, case 2, it talks about values of x that lies between minus 4 and 0. If I consider this, the first modulus sign will open with negative, so minus x minus 3. The second one will open with a positive sign, so x plus 4 is equal to 6. So this becomes nothing but x plus 3 into x plus 4 is equal to minus 6, or x square plus 7x plus 12 is equal to minus 6, or x square plus 7x plus 18 is equal to 0. And now you can see that this can be written as x is equal to minus 7 plus minus root of b square, that is nothing but 49 minus 4ac by 2a. You can see that the roots of this equation are coming out to be non-real because 4 into 18 is some 72 and it is greater than 49. So we will get nothing from here. Let us move towards the case third, or the values for which are greater than 0. If I consider this case, all the signs will open now with a positive sign. So this is what we are getting. So x square plus x minus 12 will be equal to 6. So x square plus x minus 18 would be equal to 0. And if I simplify this, it is nothing but minus 1 plus minus root of b square plus 4 into 18 by 2a. So you can see that from here we are getting values of x positive as well as negative. Negative is acceptable. So we'll get one real root from here. So you can see that we are getting two real root, hence second option becomes correct. Now let us see this very simple question that was asked in 2023. So what I can do here is, this is mod of x whole square minus 2 times mod of x. If I just add and subtract 1, this question becomes extremely simple because now this first part can be written as mod of x minus 1 whole square plus lambda minus 3 mod is equal to 1. Now what they're saying is x plus lambda is an integer. So what is going to happen here is, basically if I take mod of x as nothing but 1, in that scenario your first part will become 0 lambda minus 3 mod will be equal to 1. So lambda minus 3 will be equal to plus minus 1. So the possible values of lambda are nothing but 4 and 2. The largest element in the set would be nothing but of x plus lambda. So if I want to find the value of x, that is nothing but plus minus 1. Correspondingly, so if I want to find the maximum value of this, I can take 4 and 1 and add them. So I get answer as 5. So answer to this question is nothing but 5.
If I look into this next 2024 question, it is based on interpretation of modulus. So whenever there are multiple moduluses involved in a question, the method is very simple. In the first step, take your number line, mark all of these points. If I put this mod equal to 0, it will become minus 1. If I put this mod equal to 0, it will become minus 3. And if I put this mod equal to 0, that becomes minus 2. So we are looking into case 1 where x is smaller than minus 3. We are looking into case 2 between minus 2 and minus 3. Case 3 between minus 2 and minus 1, and case 4 that is greater than minus 1. All such questions, there were at least 4 questions in 2024 that were all based on similar ideas. Now if you move on to the second part, let us take all of these cases one by one. So case 1 is when we are talking about values of x is smaller than minus 3. Now if you are doing this, looking into values 1, so all the moduluses will open with a negative sign. So the first, this will minus and minus will become plus. So becomes x square plus 4x plus 3. And this will become plus 4x plus 8 plus 5 is equal to 0. So what we have is x square, 4x plus 4x will become 8x. And then 8 plus 5 is nothing but 13 plus 3 will become 16 equal to 0. So if I see, this is nothing but x plus 4 whole square equal to 0, the value of x from here becomes minus 4. So once you have this, you can see that this is the value smaller than minus 3. Hence it satisfies, there is no problem. This is the valid answer. Similarly, we will have to do all the cases. So if I move towards the next case, it is the third part. You look into the case 2. So we will not call it a part, we will be looking into another case. So in this case, we are looking for the values of x greater than minus 3 but smaller than minus 2. So whenever I put a greater sign, I put equal to. Whenever I put a smaller sign, I remove the equal to. If I do this, so now you can see that x plus 3 will open with a positive sign, but x plus 1 will open with a negative sign. So this will become minus of x square plus 4x plus 3. X plus 2 will still open with a negative sign, so will become plus 4x plus 8 plus 5 is equal to 0. So once you solve this, what we are getting is minus x square minus 4x. So both of these 4x will get cancelled out. We have minus 3 plus 8 plus 5 will become 13 is equal to 0. So x square is equal to 10. The value of x from here comes out to be plus minus root 10. See, root 10 is 3 point something. So from here they are getting two answers actually. Plus 3 point something something and minus 3 point something something. Since we are looking at values between minus 3 and minus 2, see, this plus answer seems unjustifiable. And this minus sign is again another one is also smaller than minus 3. So this also becomes unjustifiable. We will use the same method in the case 3 as well. In case 3, now we will look for values that are greater than minus 2 but smaller than minus 1. If I look into these values, you can see that now still, since we are looking into values smaller than minus 1, the first one will open with a negative sign. So minus x square minus 4x minus 3. The second bracket, that is x plus 2, since we are looking into positive, this will open with a positive sign. So minus 4x minus 8 plus 5 is equal to 0. If I simplify, you can see that this becomes minus x square minus 8x. So this will add up. Then minus 11 plus 5 will become minus 6. So what you are looking into is x square plus 8x plus 6 is equal to 0. From here, if I look into the values of x, it is minus 8 plus minus root of b square. So b square will become 64 minus 4ac by 2a. So if you simplify, this becomes 4, this becomes 16 and this 4 will go away. So you are looking at minus 4 plus minus root n. So now if you see the value of root 10, it is approximately equal to 3 point something. So one answer that we are looking is minus 4 plus 3 point something, and another one is nothing but minus 4 minus 3 point something. So obviously this will not come. Now minus 4 plus 3 will be minus 1 point something. So minus 1 point something might fall in this. So we need to check this. Minus 4 plus root 10 is an interesting proposition, because 3 to minus 1, it will be slightly greater than minus 1. So even this will not be the right answer. You can see that we are taking case by case, eliminating the answer. Now in the fourth case, we will go into the values of x greater than or equal to minus 1. Now in this zone, if you do it, all the signs will be positive. So x square plus 4x plus 3 minus 4x minus 8 plus 5 is equal to 0. So 4x and 4x will go away. X square is equal to 0. That is x equal to 0, and this is the valid answer because greater than minus 1. You can see that out of all the answers that we got in all the cases, there are only 2 answers that are valid because they follow the domain of that cases. Hence the answer of this question becomes 2. Now you can see that this 24 question also follows the same logic. We'll have to interpret and do it. This question also follows the same logic. We'll have to interpret and do it. And this question also follows the same logic. We'll have to interpret again into 4 different cases and do it.
If you like this video, you will also like PracBee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.